Hello, welcome to another mother flipping stream. How about that? Bet you didn't expect that shit to happen, huh? Hello. Hello everyone. Welcome to another stream. It's still kind of cold in here, not gonna lie. It's still kind of cold, but it's actually warmer than it was yesterday. But still. So hello everyone. Hello XCOMP Dux, Iguduk, UT69A Masters, by the way, Archelesis, Yetanasov, Iguduk, Raguil, Katul. Hello, really glad to see you all today. Rutifant, welcome, JTCZ, Jum, hello. Eskerashe, Mcourse 69, hello, welcome, Witness, hello. So it's already minus 25 Celsius, so yeah. Okay, let me go quickly to the kitchen, and my water just boiled up and I need to, brew some tea, and then we're gonna continue, as usual, developing shit, fake Siberia, yeah, I know. There we go. So, yeah, today is Monday, if I'm not mistaken, and that means today, according to the Skidoodle, we are developing Lisp. That's right, we're developing our own small Lisp in pure C. So you can check it out. You can check out the source code in the project command !project, or today, whatever you fancy. It's completely open source and completely free. Yeah, because I have no idea how to monetize this shit. So, and the topic of today is gonna be a virtual machine for that implementation of Lisp. So right now the language is completely interpreted, right? So essentially we parse the source code into AST, right? And then we have an interpreter that traverses that AST and interprets it and evaluates it. So the idea is to basically develop a virtual machine and a bytecode for that virtual machine. And instead of interpreting the AST, we're gonna compile the AST down to the bytecode for that virtual machine, and the virtual machine is gonna evaluate that. So this is gonna be the first step. The second step is gonna be implementing just-in-time compiler, or rather translator, from that bytecode to a native code of the platform we're currently executing on. Right, so this is going to be the next step. I don't know when exactly we're going to do that, but this is roughly the plan, right? This is roughly the plan. Yeah, nothing much to say, So I don't know, like I roughly have an idea on how to implement a just-in-time compiler, right? Again, we can just basically map a page and mark it as executable and just take the bytecode and translate it into that page and then jump there. And this is how we can, you know, make this thing executable and stuff. But I never actually like developed anything like that before, so it would be rather interesting. So the way we're gonna do that, I think I'm gonna start developing virtual machines separately from the Lisp implementation, because I never developed virtual machines. So what I wanna do first, I wanna experiment and understand how people develop and design virtual machines. And once it's ready, we can try to merge it into the eBisp and see how we can take the eBisp AST and translate it, or rather compile it into our virtual machine bytecode. Assuming you're not LLVM? So, mods, can we ban this person? Who the fuck brings up LLVM in my chat? Using LLVM for developing programming languages is like using React.js for developing websites. Yikes. Fucking yikes. Mods, ban that person. Permaban. Alright. So let's go and see what we can have here. I think my tea is ready, by the way. I think my tea is ready. Are you guys ready for a little bit of a TSMR? A little bit of a TSMR. So I'm thinking I'm gonna design the virtual machine really close to WASM, because I think WASM design is actually quite good. Right, it's like quite good, like general virtual machine. And yeah, I think I want to do something similar. It's going to be stack based, but on top of being stack based, it's also going to have so-called local variables that are accessed in have random access, right? So essentially, if we're going to have a stack on which we store the operands of particular operations, it's actually not randomly accessed, right? It's not really randomly accessed. It's not particularly convenient. So, but maybe we can add a random access. This is actually a pretty cool, interesting idea. Just add a random access. Just add a random access to the stack. I'll think about that. I'll see. So first I'm gonna go with the stack and separate local variables with a random access. P. Johannes, thank you so much for 2 months of Twitch Prime. Hi, I'm binary. Interesting. Are you talking about your gender? Thank you so much for 2 months of Twitch Prime. Thank you, and welcome back to our binary club, I suppose. But non-binary people are welcome as well, don't worry about it. So, used to the same site. I mean, this is what you get. This is what you get when you Google like binary to ASCII converter, and yeah, that's pretty much it. All right. So how are we gonna call our virtual machine? Since the Lisp is called eBisp, maybe we're gonna call it BM, not VM, but BM. Fun fact: V or letter V in Russian language is actually spelled like English B, right? So this is letter V, and it denotes the sound V, right? So we can call our machine, actually, yeah, I think it's gonna be pretty cool. Yeah, BM. So it's a virtual machine. VLisp, sounds very basic, to be fair. I'm sorry. BM sounds cool in my opinion. It sounds very Russian and it sounds very cool. Binary man. All right. So let's create a separate folder and blade machine. It's like a war machine, but blood machine. Blood machine. Blood machine. All right. So let's actually go there. I didn't even enter the link. Yeah, discrimination. I know. I'm ashamed to say, I thought you were German. Lol, this is why I'm not a trusted user. Alright, I'm not German, I'm Swedish. So, let's go to the project and start developing the thing. So, I'm gonna start with making main.c. Funkchi, what's up Funkchi? Welcome to the stream. Welcome, welcome, welcome. How about that? We're programming in C. Have you heard about this language? It's actually a pretty cool language. I think you should try it. I think it's kind of cool. I'm not gonna lie. I like it. You know what? I think we're gonna go with the traditional one. Traditional hello world. Actually doesn't have any capitalization. What, you're Russian? I would have never believed that. Well, because it's not true. I'm Swedish. Yes, I'm Swedish. All right. Let's wait. I forgot to save this thing. I literally forgot to say that. See, is this PDP 11 thing? Yes, it is. It's a it's a low-level programming language for PDP 11. It's kind of actually funny if you think about it. We are programming for 50 years in a language that is designed for machine that is not used anymore anywhere. Well, it's technically not true. I heard there is like a legacy software for PDP-11 that people run on emulators in some places, in some really obscure places. So I guess PDP-11 is kind of used to these days, but in the form of virtual machines and stuff like that. But still, we quite often use like a language that is designed for completely like different architecture, completely different machine. It's not designed for x86, it's not designed for like a PC or anything. It's designed for PDP-11 and PDP-9. Your main autocomplete, I'm using snippets, I think. I think that's what it's called. It's an extension for Emacs, for snippets. Emacs, snip. It's a German extension. Yeah, it's a German extension. And yeah, essentially you can define snippets that will expand to a particular piece of code. Right, and I think I have them somewhere here. So it's Emacs. I don't remember where it is. Yeah, Emacs snippets, here they are. And I have them like for C. So there you go, here's a snippet for main. Right, and main will expand to this. So essentially you have a file with the file name being the name of a snippet, and inside of that file you have a description of that snippet, and you even have like where should be the position of the cursor when it expands. Right, so and after that I'm able to go to my file, type main, press tab, and it automatically expands to that. So yeah, that's basically what it is. It's an extension for Emacs. You can, install it, and you can read documentation about it, how to set it up and everything. And I have a bunch of snippets for like common things that I usually type. You can find them in my .files repo if you're interested. Thanks, that's very magic. I mean, it's actually quite common thing, like to have snippets in your text editor. Like at least it was like 8 years ago. I remember that like 8 years ago, like snippets for your text editors were such a hot thing. They were as hot as multiple cursors these days in text editors. And every text editor was trying to implement like pretty cool mechanism for snippets. And this is the times from where I got them as a built-in snippets. Yeah, okay, but how customizable they are. So I'm actually quite surprised like there are people who don't know about this kind of magic. I mean, it's quite convenient. Web devs have lorem. That's actually, oh my god. Wait a second, lorem. I want to have a lorem snippet. Wait a second. Can I have a lorem snippet? If I go to Emacs snippets, right? And I think I have snippets for like global mods and stuff. I don't quite remember, but I can put them in C, in Yeah, and if I copy paste it here, lorem, right? Is that what it is? I think that's what it is. So I'm gonna put it here somewhere. And we're gonna put it here. And I think keyword has to be something like lorem. And name has to be something like this. So this is how easy it is to create a snippet, but you have to restart your Emacs. You don't really have to restart your Emacs as far as I know. You just have to reload it, but I don't remember. I think it's something like, yeah, reload. Yeah, reload all. I could have just done that. So, and it works only in C mode, but I think you can put it into fundamental mode. And if I do lorem, and there we go. So it automatically gave me like the whole text here, which is quite convenient. Right, lorem, there we go. So that's how it works. So that's how easy it is to create a snippet, if you're interested in that. Oh, so it has a function for creating new snippets. Nice. Yes, new snippet. Oh shit, that's actually pretty cool. Okay, it actually puts it in the mode where you currently are. Okay, that's interesting. So wait a second. Can I quit this shit? Okay, I'm gonna quit it. So if I go to the fundamental mode, for example, fundamental mode, and I do yeah new snippet, it's going to create that thing for the fundamental mode. Nice. Thank you so much. I'm gonna keep that in mind. Alright, so let's go back to the development, right? Because nobody gives a shit about editors, right? Everyone here for a virtual machine. So let's actually build our virtual machine. We're gonna use makefiles in 2020. I know. It's pretty dank to use something like that in 2020, but it is what it is, and it isn't what it isn't. There's nothing you can do about that. Alright, C flags. So it's gonna be O, BM, lib. C. So what kind of C flags we're gonna have? We're gonna have W all. We're not gonna have W error. We're gonna also have extra thick warnings. Then we're gonna have a standard C11. Right? We're gonna have a C11 standard. We're gonna have pedantic. Do we need anything else? I don't think so. So that should be all right. We're not going to link with any libraries yet, and to be fair, we don't really need to link with any libraries except libc and libm. Excuse me. I'm sorry if it was too low. Let's try to build this mother flipper. Let's try to build it. And it doesn't even build, because I forgot to provide the input file. How about that? So it has to be main.c. Extra thick funny bone. Alright, so let's try to compile that, and yeah, we have unused variables. Well, if we're not gonna use them, we might as well remove them. Thank you, compiler. Very cool. And now we have a BM, and if you run the BM, it says hello world. How about that? So let's go ahead and create a virtual machine. So we're literally gonna have a structure that is called machine, believe it or not. I think it kind of makes sense if you're implementing a virtual machine. It only makes sense to create something like machine. Or maybe we're gonna call it BM, right? For virtual machine. Now we need snippet for makefile. That's a good point, actually. Let's create a snippet for makefile. I kind of like that. So, yeah, new snippet. Make, and what we're gonna put there? Let me see. I'm gonna put this thing here. So I think this is what I need to put here. This is gonna be the second one. This is gonna be the second one, and I think this is gonna be the first one. Yep, I think that should be it, if you ask me. Okay, we saved it to make, right? So here's the yeah, create it, make, load it, cool. So do I have to reload it now? So Oh yeah, bm main.c. Ah, shit. There we go. So you see, you can kind of like reuse the same things, as you probably saw. Snippets, make file, gmake mode, make. So you see, this is actually quite important. Like I have 1 and 2 here, and 1 and 2 here. So basically it will ask you only once for the name of the target and the name of the dependency. And then it will reuse them here without asking you any further. This is actually super important. As I showed you before, look. Right, I type the name of the executable, bm, and as you can see, it types it here. I press tab, main.c, it also types it here, and you can reuse it for as many times as you want. Sometimes it fucks up the tab for some reason, but I don't know how to fix that. But you get the idea, right? So basically we can have a snippet for that, and it reuses some of the parts of the snippets and shit like that. It's actually pretty cool. I haven't used like snippets for quite some time already. Can you have make a snippet for snippets? Yeah, I think you can, because snippet also has a mode, so it can be self-referential. You can have snippets for creating different snippets, right? So I don't quite understand why tab doesn't work here properly, but what if I put /t here and then I reload all? Yeah. So and then I try to do something like this, make. And it actually puts /t there. So sometimes I don't understand, but it doesn't really work with spaces properly. Does anyone know how to work with spaces properly? Like snippet, spaces, and tabs. How to insert leading spaces in snippet? Yeah. So this is kind of a problem. Look for expand. Expand environment. So to the answer you're looking for, browse the question, snippet. Okay, so basically it's a special flag, right? It's a special flag, and we have to enable it. Okay, so that means here I should be able to. So it actually inserted the spaces instead of the tab, but I actually need a tab. Yeah, okay, this is a tab. It's quite important because make requires you to have tabs. Okay, so now if I do reload them, and I do make, and as you can see, it has a tab. So basically it's a flag. I don't know why it doesn't insert like leading spaces, maybe because of the indentation mechanics in Emacs or something like that. But overall, I think that's how you can do that. Yes. So now we have a snippet for make files, because I quite often actually type them. But maybe we're gonna have like a different snippets for different languages, like this one for C. We probably want to have like for C++ and something else. So yeah. Anyways. Cool, so we're gonna have a virtual machine. As I already mentioned, we're gonna have a stack, right? Stack is gonna be just an array of some sort of words, right? So it's gonna be a single word. You can put some word on the stack, and we're gonna have a stack capacity. And the question is, what is gonna be the word? So for now, we can say that it could be something like, well, it could be a structure as well, right? It could be literally a structure with like a type of word. It could be like integer or something, like basically how to interpret that word, but I also want to keep it like the same size. But maybe for now, we're gonna keep it int 32t, so, or maybe 64, because we are on a 64 machine. Come on, it's 2020. So this design is not final, so we don't really know how the design is gonna turn out in the future. It's probably gonna be redesigned. So, and also we're gonna have like a limited capacity of the stack. So what's gonna be the capacity of the stack? Is 256 words enough for everyone, or maybe 224? Maybe in the future it's also gonna grow, but for now I just don't want to think about memory management, so this is gonna be just like this. Yeah, and we also can allocate stack on a static memory, I mean machine on a static memory, and it's going to be zero initialized. Everything is going to be zero initialized here. And also maybe we want to keep track of the stack size, how much already filled there, so we can have stack size. Yeah, so once you take a virtual machine and zero initialize it, as you can see, it's that. So the next thing we need to do, chat, we need to have some sort of instructions, right? So an instruction is gonna have different types. I would assume something like type def and num. Right, so what kind of instructions we're gonna have? We're gonna have an instruction inst push, so you can push something onto the stack. Then you probably wanna sum up first two elements on the stack, on the top of the stack, and push them back into the stack. So, and this is going to be instruction type, right? So right now we're going to have only two instructions. So you can push something on the stack and you can sum it up. Make sense? Hopefully that makes sense. All right, so then we need the structure for the instruction itself, right? The structure for instruction itself. So it's going to be called inst, right? And again, I have to use type defs because I'm programming in C, right? Something like this. And we're going to have inst type. So here's the type. And we're also going to have like an argument, like an operand. So right now it's going to have like a one operand. And I guess that's it for now. Wearing hat all the time may be bad for your hair. No oxygen for the roots. It's too late. Oh, it's cold inside, okay? So where have you been? It's too fucking late. Come on. To be fair, it's actually kind of annoying to wear the hat all the time. Alright, so let's not wear the hair. Okay, so this is the instruction. Cool. Now, what we need to do, we need to implement a single function that will execute an instruction, right? A single function that executes an instruction. So execute inst, right? It will accept a pointer to the virtual machine, right? To the virtual machine and the instruction itself, right? The instruction itself, and it will just execute it on the virtual machine, right? The virtual machine is a stack, and it will just execute that. So let's quickly implement it. How we're gonna do that? So we're gonna switch upon the type of the instruction, right? So, and what kind of instructions do you have? We have that, right? We're gonna put it here, and it's gonna be case, and here we're gonna have this thing. This one is going to be break, this one is going to be break. So when we are pushing on the stack, so what we're essentially doing is we take the stack size plus, and we put that one operand onto the stack. So this is how we push on the stack. Why not Ushanka? I don't have an Ushanka, and to be fair, I don't like Ushankas. I think they're kind of annoying to wear and take care of. It's just... Beanies are way more comfy, in my opinion. I know I'm a fake Russian, right? I don't drink alcohol, and I don't wear Ushanka, I'm sorry. Fucking Western spy, am I right? Here's an interesting thing. So what if you don't have enough space in the stack, but you got volume? No, I don't have volume. Okay, sorry. So we can just assert that shit for now. Yeah, we can simply assert that stack is less than BM stack capacity. stack capacity. There we go. We can just assert that. Do you have ladder? I don't have any machine except the virtual one. Fuck, I'm speaking. Yeah, okay. I don't have any car. Holy shit, I have a brain fart. Okay, so the thing is, in Russian language you call a car a machine. Right. That's very interesting. So as you can see, I just proved that I'm not a fake Russian because my brain still thinks in Russian. How about that? Okay, no car, not kick crowd. Okay. All right. So what's going to be the next thing? We need to do an assert. Do you have car and CDR? Yes, I do have car and CDR. Have a bear as a pet? No, I don't have any pets. I'm not allowed any pets in this apartment, unfortunately. I wish I had a pet because sometimes it gets quite lonely here, but unfortunately I'm not allowed to. All right, let's continue. Actually, like calling a virtual machine Lada is not a bad idea. What pet would you like? Probably a cat, I think. I like cats. They're quite comfy. I had a cat in the previous apartment, so I don't have a cat here. Alright. Okay, so here, what we have here, right? So we're doing the plus operation, right? We're doing plus operation, but you can only perform plus operation if you have enough arguments on the stack, right? If you have enough arguments on the stack. Zombie Cho subscribed at tier 1. Oh my god, thank you. Thank you so much for tier 1 subscription, your first subscription by the way, and welcome to our epic virtual machine club. How about that? How about it? Okay, so maybe I'm not gonna assert anything. I'm not gonna assert anything, and I'm gonna basically return a special type when some sort of an exception happens. What's interesting is that, as far as I know, in WASM, right, an exception that happens inside of a virtual machine is called a trap. Like, it's kind of like similar to how it's done like in x86, but in x86 trap is some sort of like interruption thingy. We can actually use the same terminology, right? We can try to use the same terminology. I kind of like this terminology. It's going to be enumeration, trap, and it's going to be stack overflow, for example, for this situation. For the situation when we have a stack overflow. And we can also have a trap stack underflow, right? Stack underflow. So when you're trying to perform a plus operation and you don't have enough arguments, right, it's going to be a stack underflow. So we can also have other exceptional situations here. I just don't want to use the word exception. So I just don't want to use the word exception. So we're going to return trap. So you have a virtual machine, an instruction. Oh, and by the way, since there is nothing wrong happened, you can have like trap okay, right? So it's going to be 0, and that means everything's okay. The trap was not executed. So it's quite important to have something like that because you want to be able to handle exceptional situations in the virtual machine, right? You want to be able to handle them to display something properly and stuff like that. So it makes sense to return something. So, for example, in this particular case, if the stack size is greater or equal than the capacity, right, instead of performing anything, we just have to instantly return trap stack overflow. There we go, stack overflow. Alright, stack overflow, and in case of a plus, like if BM stack size is less than 2, if you don't have any operands, this is trap stack underflow, right? Underflow. So, and then what we can do here, we can do stack size -1. So this is the top of the stack, but we have to actually go one step back, right? Because essentially if you have like this stack 1, 2, 3 and you perform a plus operation, what you're essentially doing, you take these two arguments and sum them up and push them back onto the stack, right? You push them back onto the stack. So the easiest way to do that is take the previous frame of the stack and add the top of the stack and simply reduce the size of the stack, right? So we can like manipulate on these things directly. We can manipulate them on this thing directly. Are global variables okay? What is a global variable? Okay, so I guess this looks okay. Global variables are perfect. Well, yeah, I guess. So global variable is a variable that is visible for your entire program. But what's interesting is that global variables are not visible outside of your program, right? So, for example, if you have a bash script that calls other programs, each of these programs have a lot of global variables, but none of those global variables are visible to your bash script. So, are they really global variables if they're not visible outside of your program? Maybe they're not that global after all. Do you see my point? Anyway, so let's continue. So we're also gonna have something like default, and in case of the default situation, we can have something like illegal inst. There we go. So this is another exception that can happen. We can have stack on overflow, stack underflow, and then illegal instruction. So for example, we only have two types of instructions here, push and plus. And if we hit default, this is a straight up an illegal instruction. So, right. And after that, we can return OK. There we go. So we handled everything, and we handled each individual situation here. So should be all right. Should be all right. And I think we technically implemented a very simple virtual machine already with a stack that, you know, supports a plus operation. Supports a plus operation. So let's actually implement another thing. For example, I want to be able to dump the virtual machine, the state of the virtual machine, just to inspect how it's going on. All right. BM dump, and we're going to accept a constant pointer to BM. And what we're going to have here is, I suppose we're going to just print stack. Right, we're going to print the stack. And how we're going to print it? I think we're going to print it in a reversed order, but maybe not. So this is going to be that, and I'm going to start iterating 0 less bm stack size plus I print f, and this is what we're going to have here. I think so. Word is int64, right? So that means it has to be something like, I don't remember, it's like long D or something. Yeah. Not BN, BM stack I. There we go. So that will print the whole stack. Okay. I also want to have a way to quickly construct instructions. I think there should be a way to do that. There should be some sort of a constructors. Let's actually try to implement them. So inst push, right? And it will accept just an operand that you want to push. And essentially is going to be this thing. Might as well actually do it like that. What's up, Todding TOS? Welcome to the stream. Size T is unsigned, so at least LU, maybe LU. So hopefully I have a lot of warnings, by the way. A lot of warnings. So hopefully the C compiler will tell me what exactly I have to put into the printf. Because as far as I know, some of the flags actually checks this format arguments, which is quite convenient in GCC. Yeah. Okay, so we're gonna have a type. Finally, I can use designated initializers. I absolutely missed them in C++ because they're only available in C++20. In C, I can finally use designated initializers. I absolutely love them. All right, inst push, and the operand is going to be the operand. C is just, yeah, C is like a little bit better than C++, but there are some things in C++ that are kind of better than in C, specifically the type system. It's a little bit stronger. I like that. We'll be using some bits in the operand to tag it as a particular type. I will think about that. I was also thinking about using NaN boxing or something. You know, it's quite often used in interpreters and stuff like that, but we'll see. We'll see. I haven't decided yet. I only started to develop this virtual machine. I'm not sure how the design will go. All right. We write in C++20 at work. Designated initializers is indeed my all-time favorite feature. Yes, they're very useful. Okay, so this is going to be inst push, and another thing we want to construct here is inst plus. So it's not going to accept any arguments here, and it's going to be simply inst type inst plus. So there we go, there we go. So we have a virtual machine somewhere here. So BM, here it is. I'm gonna keep it allocated on the static memory. So it is allocated on the static memory. And let's try to dump it on the standard output. So it's gonna be something like this. Let's see how it's gonna go. The moment GCC had beta C++20 compliance, maintainer moved all our projects to it. Nice. All right. Okay, so something doesn't... Okay, I keep confusing BN with BM. If I try to run the virtual machine, there we go, the stack is absolutely empty. The stack is absolutely empty. Maybe it makes sense to indicate that. So if BM stack size is greater than 0, then do this thing, right? Otherwise, print empty. Like this. So there we go. We can clearly see that the stack is empty. All right. So then what we can do execute instruction on the virtual machine, and the instruction that we want to execute is going to be push. We're going to push 69 onto the stack. And after that, we want to dump that machine yet again. And there we go. So here's the first step. The stack was empty, and we pushed 69 there, and there we go, we have 69 there. Okay, so the next instruction is going to be pushing 420, right? So you see, we have a virtual machine, we execute an instruction, and it just pushes another number there. So here's the trace of the virtual machine empty stack, 69, 420. So cool. And another instruction that we can push now, we can push plus, right, and execute one more time. So what's gonna happen? Well, we push 69, then 420, and then we sum them up and push them back onto the stack. We push them back onto the stack, and there you go, we have a proper virtual machine. How about that? How about that? I think it's kind of cool. So the next step would be probably have something like a program, right, where you can have a bunch of instructions, right? I wish I could easily just push this thing here, but I think in pure C it's kind of painful to do things like that, right? I think it's not gonna work because that will require compile time execution of these things, right? And I don't think it is a thing in C, but we can try, So also I want to have some sort of a macro that gets the size of the array. Size of access divided by size of access 0. That's what I'm trying to achieve here. But in this case, it would make sense to do it like that. Right. So, and let's try to execute the program. Right. Let's try to execute the program. So this is the initial state of the virtual machine. And then we're going to iterate through each individual instruction here, array size. Sorting is a functional expert. This is lie, by the way. So program, and this is probably why you got timed out, because you're spreading lies. Would you show a sample on reactive programming with JavaScript? I would subscribe to your Twitch podcast. What is a Twitch podcast? I don't have a Twitch podcast. What are you talking about? Holy shit. Oh, okay. So I'm just writing the virtual machine here. I'm just an old 30 years old bald man writing the virtual machine. What do you guys want from me? Stop harassing me with podcasts and stuff. Podcast when? Right now? I don't know. Like, what podcast are you guys talking about? I mean, I use pods. There you go. Here it is. It's a pod. I'm programming in C. There's nothing but pods in here, and I do cast them quite a lot. So is that a podcast, right? When you have a pointer to a pod and you cast it to another pod, is that a podcast? That's why I don't have any friends. All right. So let's continue. Yeah, let's execute some shit. Execute instruction. So it's gonna be pointed to the BM. And it's gonna be program I. Okay, so this is actually quite important. Humor so bad maybe kick crowd after. All right. So any execution of BM, by the way, any execution of BM may result in a trap being activated. It's kind of dangerous, not gonna lie. So, and this is what we're gonna put here, right? So, and if trap is not trap okay, we'll have to stop the execution and actually print what's happened and also print the dump of the virtual machine. So how are we gonna approach all of that? So I need a way to actually take the textual representation of the trap. So let me do something like trap as CSTR. All right, so this is gonna be const char, and we're gonna accept this thing here. So this is gonna be a switch. We're gonna switch upon this entire thing. Archelaus, I didn't say anything, okay? I didn't say anything. Let's query replace this entire stuff. And a boom. So let me also think. And we're gonna simply return this thing like that. But what's funny is that not funny, but interesting, is that this may happen. Even though we're handling all of the possible cases, this kind of stuff still may happen in pure C, because it's not a safe language, it's not as safe as, for example, Rust. Hence Chenker subscribed at tier 1. Thank you. Thank you so much for your subscription, and welcome to our epic virtual machine club. Welcome. Cheers, by the way. I'm running out of tea. I think I will have to make another cup of tea. C will detect that you have covered all enum outcomes. Yes, it will. But for example, what if I have a pointer to array of traps, and that pointer points at incorrect memory accidentally, and I'm iterating through an array of traps, and I call it trap as sister. Because of that, this switch may actually fall into the default, regardless of whether it tap checked or not. And by the way, that happened to me, and that happened to me way too fucking often. It was actually quite surprising how often that shit happens to me. So, what does being safe or not safe mean? It doesn't mean anything, it's just a marketing bullshit. My subscription is for JavaScript React representation. You will do it in near future. No, I won't do it in near future, and subscriptions are not for making me do anything. If you disagree with that, you can actually refund your subscription. Right, so if you're subscribing to me, I assume that you're subscribing to me to support my channel, right? Not to make me do anything. If you want to make me do anything, you've come to the wrong channel. Please find another channel where people do that. And I think you can go to subscriptions, right? I think it's twitch.tv/subscription, or maybe so. And within a certain period, you can actually refund your subscription, right? So you can actually, like, there will be a button here. Just go there and click on it and unsubscribe from me, and the subscription will be refunded. Thank you very much. All right, so let's continue. So in case of a default, we can actually write an assert, and we can say something like unreachable. Reachable, unreachable. There we go. Beanie stream, yes. Hello, Forth. Welcome to the stream. It's just a little bit cold in here because I'm in Siberia. So, so yeah, a Beanie stream. How about that? We're developing virtual machine, by the way. For how about that? It's actually pretty cool. I never developed a virtual machine in my entire life, and it's feels pretty goddamn amazing. So yeah, it feels pretty goddamn amazing. I think I'm also gonna do something like trap as sister, unreachable. So this is how it's gonna go. And if trap is not okay, this is exactly what we're gonna do. We're gonna do fprintf std error. Trap activated. Trap activated. And what exactly was the trap? Trap as sister. Trap, and I think this is what I have to put here, and then we're gonna actually exit with 1, right? And we also need to dump BM to the standard output. Well, in that case, we need to dump it to the std error. I think this is what we'll have to do here. Cozy White Bear, welcome to the stream. Welcome. So as sister, and so this is the virtual machine that we'll have to do here. There we go. Chat, calm down. Chat, relax. It's a computer science terminology. I don't know what the fuck you're talking about. Okay. So stop. Fucking stop. Because, like, I don't want to use word exception. First of all, exceptions have bad reputation. Second of all, they're too long. So it's such a nice short word that is very convenient to use in code. Okay. Yeah. Except, yeah. Alright. Chat, stop. Chat, stop. MongoDB. Okay, so we accept a stream here, and I think this is exactly what I'll have to do here. I'll have to take f stream. There we go. So this is how we're gonna do all of that. So if it's not okay, we say that this thing was activated, and we dump the state of the machine, and then we continue. Okay, and it doesn't even compile because exactly what I thought it is, right? Because this thing is not executable at compile time at all. And we don't have const expressions in C. 2020. Where are my const expressions in pure C? I don't want to use C++, I want to use C. Where are my const expressions? So if I make if I make this thing inlineable, will it help? Like static inline. I wonder if it will be able to optimize that, like to, you know, compile time. Initialism is not constant. Okay, you know what that means, chat. You know what that means. We all know what the fuck that means. Fucking macro time. Inst push, and I already have inst push. Let's call it make inst push then. So this one is going to be essentially inst, and this one is going to be type inst push, push, and the operand is going to be operand, like this. And this is going to replace this entire shit, right? And then we're gonna have something like plus, right? There's gonna be something like plus, and this doesn't take anything. We might as well actually make it like this. It's gonna be only plus, but it doesn't have any operand, right? So it's gonna be like this. And what we're gonna do now is this. It's gonna be make, boom, boom. And in this case, I don't need that even. So can I compile it now? I cannot compile it now because why? Make ins pushed. Oh, because it has to be plus. Yeah, there we go. There we go. Now we're talking. Expected identifier before numeric constant. I'm sorry. So this is an operand. So then it's that. Okay. I don't see any problem here. Identifier before numeric function understandable. I think it's just what is going on? What is going on? Chat, is everything okay? Are you okay there, chat? Oh shit. Okay, so let's actually call it value then. Yeah, I see what is going on. It's so dumb. It is very, very dumb. By the way, Jiang. Hello. Initialize element is not constant. That's very interesting. So it's a warning though. It's a warning though. And this is going to be std out. Just hello, Jiang. Hello. Okay, so, and after the execution, right, if you do something like dump std out bm, you're gonna have that. So yeah, there we go. Here's the program with different instructions and shit. And we execute it on the virtual machine and everything's okay. We can try to, for example, remove these two instructions and witness a trap. Trap activated, trap stuck under flow, and you got the current state of the virtual machine. There we go. So that's how it's gonna go. We might as well actually reduce the size of the stack to just 1, and that will actually activate stack. You too, Jiang. Okay. Like I already explained, I don't want to use word exception, it's too long and have bad reputation. Trap is a terminology from WASM, by the way. Like WebAssembly literally uses like word trap for error. We can use error. Okay, let's use error, sure. Maybe. Okay. There we go. Error. I mean, it's a MongoDB, okay? It's a MongoDB. Be careful, chat. So how can we make it like really constant then? How can we make it constant? It's a good question. If I make it like this. Oh, okay. So this is actually constant now. This is actually constant. All right. Is stream okay? Stream is okay. Iguduk, please tell me that the stream is okay. Thank you, Iguduk. I really appreciate it. All right. I swear to God, you guys one day gonna get me banned. And you know what? You're the one who's gonna miss my streams, right? So, you know... Anyway. Let's continue. Just for the record, by the way, we are completely against of transphobia or any other bad stuff. So yeah, please, Twitch, don't ban us. So yeah. Anyways, so maybe we're gonna make a cup of tea. Maybe we're gonna make a cup of tea. Do you guys have any questions that you wanna ask me? Cheers, by the way. TS Coding, do you have any solution for restoring previous session workspaces in i3WM? No, I don't have any solutions, to be fair. I actually restore them manually all the time. All right. So I'm gonna quickly make a cup of tea. Does anyone have any questions while I'm making a cup of tea? Do you work before streaming? Do you work before, or is it your job? I don't have a job. Let's put it that way. Streaming is not my job. I don't like to consider it my job because I hate job. So essentially, I just like to consider that I'm complete NEET. So yeah, don't have a job. What is your boomer tea apparatus? It's a French press. Yes, I'm making tea in a French press. Can you explain the macro lines if you don't mind? Sure. So let me see. Where are the macro lines? So essentially, if you call this thing, it will be literally substituted with this at compile time, like on the text level. So it's almost like if I took this text and copy pasted it where I call make inst push. So does it make sense? A question was your intention to sometimes stream in ADA again, a joke, or we should expect another stream in the near future? Yeah, I do plan to do something in ADA, but I'm not really sure what exactly, so that's the problem. I would like to start a project in ADA, but I don't know what to start in it. Have you done any work on the genetics and the intersection with software engineering? I streamed a little bit of genetic programming. Does it count? Borel VI. Oh, it's not Borel. Please compile. Please compile. Thank you so much for Twitch Prime subscription. Thank you, and welcome to our virtual machine club. How about that? So, does the genetic programming count? I think, yeah. We don't even have a command for that. Let me find it. So essentially, I was just optimizing some stuff using genetic programming, and I also streamed that. There are some links to playlists and stuff like that. Some highlights were made by Kolumbetka as well. So yeah, does it count? I won't ask you to build things for me. I'm just happy with. Thank you. Thank you so much. Okay, so we have a virtual machine that can do things. What else should we do? I think we should start adding more operations. Something like minus operation, multiplication operation, and division operation. What do you guys think? We need to add at least those things here. T-type. Yeah, I'm drinking Earl Grey right now. Hello, Draco. Welcome to the stream. Space Wars. Hello. Multi-threading in VM when? Maybe a little bit later. Hello, Jazz Ibot. Welcome. Will this actually target some Lisp dialect, or is that a meme? So we're developing our own Lisp. We're developing our own Lisp. You can find the source code of the Lisp here. Right now, it doesn't have any virtual machine, and what I'm doing right now, I'm developing a virtual machine for it. So yeah. That's basically what's going on here. I never developed a virtual machine, so I'm just playing with the concept here. So what other operations do we need here, chat? What other operations? Plus, minus, multiplication, division, some bit stuff. But maybe we can implement some bit stuff a little bit later. Jump, well, the jump is definitely needed. So first I'm going to implement these things. And then we're gonna go to the jump. What's funny is that, why don't I have, I remember, I need a special flag for switching. So does anyone remember what was the switch flag that basically also allows you to have default, but even though you have default, it will still tell you that you didn't cover some stuff. Does anyone remember what it was? I think. Okay. So let's actually go to man GCC. Okay, GCC switch Oh, switch enum. Yeah. Switch on enum, retain missing warnings. Okay, thank you. Let's actually enable that. Switch enum. Cool. And I need to do -b. And there we go, now we're talking. So yeah, essentially it says us that we don't support minus. Let's implement minus. Oh, Helmut's shader. What is going on? Nice shirt. Thank you. Thank you for $5. Thank you for supporting the channel. It's actually a pretty old shirt. So I guess it's still good. Thank you so much. All right. So we need a minus separation, and minus separation is actually quite simple. I essentially can copy paste this entire thing, and instead of plus, put minus here. There we go. What else can we have here? So we need also multiplication, right? Is inst mult. And guess what? I can implement multiplication by literally doing this thing, but just multiplying instead of minus. And and for division, I can also copy paste this entire thing. Yes, div. But instead of multiplication, we're gonna do division. There we go. So now we support more arithmetic operations. It was that goddamn easy. So here we can have a plus, and then we can, for example, subtract another value, 42. And how we can do that? We can do that by doing inst minus, and that will not compile because we don't have such a macro. We don't even have such a macro, so we also need to create it. Make inst plus, and this one should be pretty easy. So this one is going to be minus. So then we can implement one for multiplication, and another one could be for division. What is going on? Alrighty, cool. But I like to, yeah, I was thinking about division by 0. Don't worry about it. Okay. Before I go into that, I think on each execution, I want to actually print the state of the machine. What is the plugin for debugging? I don't debug anything right now, and I don't have any plugins for debugging. I usually debug through a GDB. And it's not a plugin, it's a separate program. Relative line numbers, this is the second time I've seen this. Question for anyone, why would anyone use relative numbers? I can show you why. So in editors, there's an interesting thing called command repeaters. For example, in Emacs, if you press up, you can actually tell Emacs to repeat that command, for example, 10 times. So essentially what relative numbers show you is how many times I have to repeat down to reach this line. I know that I have to repeat it 18 times, and I'm already there. Does it make sense? So I can just look at that place. Okay, I need to repeat up 21 times, and I'm already there. So yeah, to repeat a command, you hold Control and you type a number. So you hold Control and you type 2, 0, and then you press down. And it repeats that command as many times as you said it. And actually you can repeat any command this way. For example, I want to insert dash 30 times. I type Control 30 and then dash, and it inserted dash 30 times. You can repeat anything this way. How do people learn about how to write a compiler VM? I guess they read books or something like that. I'm a self-taught programmer and I too want to do awesome stuff like this. Does anyone remember the crafting compilers book? Can anyone please send a link? I know Feng Chi actually read this book, but I never read it, but I heard that it's actually quite good. Crafting interpreters, yes, it's crafting interpreters or something. I think you should be able to Google it quite easily. So I guess this kind of stuff is explained there, but I never read it. So the way I learned it is I basically read how computers work, right? And what I know is that virtual machines are basically simulating like very simplified computers. So what I'm doing is I'm simulating a very dumb computer. That's it. So I don't need to read anything about that. So does it make sense? I just go ahead and simulate the computer. Like it's not that hard. If you know how a computer works, you can just simulate it. Where did you learn about how computers work? I mean, I'm a programmer. To be a programmer, you need to know how computers work. I mean, so you're self-taught programmer. How do you program things if you don't know how the computer works? Right. So the usual concepts, like a stack, right? Your memory, the current execution pointer, right? The registers, you know, all of this stuff. How do you program without knowing these things? I don't understand. I don't know. So like it's something that you know if you want to be a programmer, right? You know, memory, stacks, stack frames, execution pointers, all of that. You just take that and you simulate it. That's it. That's simple. Yeah. Okay. Cool. So, and again, so we're trying to execute this on each individual thing. And we have stack underflow, which is actually kind of strange. All right. Where is the program? Okay, you push 42 and you have to do minus, but that didn't really work well. So I'm kind of confused. Oh, by the way, I forgot to make a cup of tea. So just, I'm gonna go to the kitchen real quick, turn on my kettle, and I'm gonna go back. Don't go anywhere or you're banned. Yes, I have a bot that keeps track of everyone. And if anyone leaves while I'm in the kitchen, it instant bans you. So you won't be able to talk in this channel ever again. So don't go anywhere. I'm gonna be back very soon. What's up? How's it going, everyone? Welcome back to Back Champions. Alright, so I also want to print the instruction every time I'm about to execute the instruction. Right, so but to print the instruction I need to be able to take the instruction type and print it. So let's quickly do that. You know what? I have an idea. Let's do something like const. It's gonna be a little bit painful, so let's do const char. Inst type as sister, right? We take inst type and we're gonna do the following thing like this. It's gonna be switch type like this and like this. Query replace this with that. Boom. Then yet again. Case. And let me actually quickly do something like this. Break. Maybe we can do a return where I could do this. And I'm gonna just return the textual representation of this entire stuff like this. And on the default case, we can say that this thing is unreachable because it should not be reachable. So I get them. Unreachable. There we go. Cool. So now we can take an instruction type and turn it into a string so we can actually log it. We can actually log it. And so here we have what? So we're going to print S program I before executing it. Then we execute the instruction and then we have everything here. Okay, so something went wrong. Yeah, it has to be inst type as sister, and then I take the type of this thing. Cool. So type. And oh my god, I'm an idiot. Chat, I'm an idiot. Masters, by the way, subscribed at tier 1. Holy fuck, thank you so much for your subscription, by the way, and welcome to our epic virtual machine club. How about that? How about that? Inst type as a sister. Thank you, thank you, thank you. Really appreciate the support of the virtual machine. Okay, so you push, and something strange is going on. I think I did a fucky wacky somewhere, but I'm not sure where exactly. So in the plus, I just do plus and I increment, minus, multiply, and I always increment, but I don't see any problems here. So what if I... So there should be something plus, minus, multiplication, division. Something is wrong. Does anyone know what is wrong? So after push we have 69, after another push we still have 69. It's almost like it doesn't push anything, and I wonder what the fuck is going on. Why it doesn't push anything? What the hell has happened? What is a stack underflow? It's like stack overflow but the opposite, right? So it's when you are trying to pop out of the empty stack. Oh, the stack capacity is 1. Goddamn, thank you. Thank you, PS Comsci. Yeah, I completely forgot about that. So essentially, you have an empty stack and you're trying to get something out of the empty stack. Well, it's opposite of stack overflow. It's stack underflow, right? So where stack overflow is where you push into a full stack. Exactly. It's just opposite of each other. And there you go. So yeah, we have that and that and that, and cool. So after that, I want to push something like make inst 42, and then we're going to try to subtract that. So it's going to be minus. And it's not plus, it's push, right? It has to be push, and there we go. So at some point we pushed 42 and we subtract it, and then I can try to do another instruction here, make inst push, I don't know, 2, and then I'm gonna make inst multiply. So I'm gonna multiply it by 2 and see how multiplication works. And multiplication worked quite well, so we can just multiply all of that finally. And now we can try to do a division. We're gonna do make inst push 0, and we're gonna try to divide it by 0 and see what's gonna happen. What's gonna happen if we divide by 0? Compilation floating point exception at Monday, December 28th. Yeah, it's actually quite bad when a floating point exception happens at Monday. So yeah, in that case I need to go to kitchen and actually brew up some tea. So that's what I usually do when a floating point exception happens at Monday. Yeah. Fucking coming. I came. Welcome. Masters, by the way, holy shit, is gifting 5 tier 1 subs to the Zozin community. Thank you so much for supporting the Zozin community, and everyone who's got the sub, Boomcha, Brain Compiler LS, LC, Cody Murph, Flomix, and Diablo SSL. Welcome to our epic virtual machine club. Hello, welcome, welcome, welcome. Enjoy your... Yes, Boomcha, you are now a subscriber. All right. What's the VM name? It's called BM. That's the name of the virtual machine. It's called BM. Boomer machine, I suppose. Yeah. Virtual machine, yes. Oh, I fucking know. It's a virtual machine, and the logo of that machine is gonna be birch. Yes, it's gonna be birch tree. That's actually perfect. It's a virtual machine, and the logo is birch. I think that's cool. I think that's fucking cool. And it's also very Russian. Well, some people may argue it's also very Swedish, right? But anyway. Brutal machine. Maybe brutal. Today, so many people are subscribing to Zozing. I guess, thank you so much for subscribing, everyone. Thank you. I will finally be able to pay for my heating in my apartment because I'm freezing. Thank you so much. Anyways, so we need to protect from the division by 0, right? We need to protect from the division by 0. So instead of like crashing the whole program, what we can do, we can make this a separate error, right? Error div by 0. So this is literally going to be yet another error, and we also can check that. So if you do a division, if you don't have enough operands on the stack, it's a stack underflow. If the element by which you are about to divide equal to 0, this is instantly error div by 0. So this is how we protect from that. This is how we protect from them. As you can see, assertion unreachable, and yeah, we don't have a textual representation for error div by 0, and we can return error div by 0. The other day, Big Boy suggested soundtrack to for background music. Search for what? Okay. All right. So as you can see, we have an error div by 0. To be fair, we might as well actually not print this thing. I think. Yeah, there we go. So we do a division, and there we go, we have an error division by 0. So, which is quite cool. So instead of that, we can try to divide it by 4 and see what's gonna happen. Yeah, so we divide it by 4, and there you go, we have that. So all of the instructions work correctly. What is the sound of one hair falling? Don't make a deadpan, please. Don't make a deadpan. How's the color of the stack in the error are different? I think this is because of Emacs. Emacs detects this pattern, like a word column, and colors them differently. So I don't do anything special for that. I think it's purely Emacs. I do think it's purely Emacs. Anyways. Let's do a little bit of a TSMR. How about that? Let's do a little bit of a TSMR. Why do you have the size of your porn folder on the bottom of the stream? Because I'm proud of it, and I'm not ashamed of it. Okay. So, yeah. Are you guys ready for a little bit of a TSMR? I'm a grown-ass man, and I'm not ashamed of my porn folder. Okay. I don't have to hide it from anyone in a different folder named homework or anything like that. I don't have to do that. Okay? So you should be ashamed because, well, it kind of is small. So yeah, subscribe so I can buy more porn. I'm joking. Don't subscribe for that. I cannot stream porn on this platform. Okay, it's a kind of against TOS of Twitch, and I could probably stream that on Chatterbait, but unfortunately I already have a contract with Twitch, according to which I cannot stream on other platforms. So I wish I could stream on Chatterbait, but I cannot. Sorry. PoyJN23, thank you so much for Twitch Prime subscription. Thank you, and welcome to our epic virtual machine club. Cheers, by the way. Alrighty, so I guess we have enough things for integer arithmetics. I think we have enough things for integer arithmetic, and the time has come to make our virtual machine, Turing complete. And the way we're gonna make it Turing complete is by adding conditions and loops. Let's start with loops, right? Let's start with loops. Essentially, a loop, to implement a loop, we need another kind of instruction. And this is going to be just unconditional jump. So you basically jump to a specific address, and that's it, without checking any conditions. Masters, by the way, thank you so much for gifted another 5 tier 1 subs to the Zozin community and MVP 135, as Neh, Video Nomad, Zbiz, Timo JL, welcome to our Epic Virtual Machine Club. Right, so essentially what this instruction is going to be, it's going to be an instruction that has only one operand, and that operand is the address to which you have to jump, right? So let's try to implement that. So we're going to define make inst jump, right? Make inst jump, and it's going to be type inst jump, and the operand. So this one is going to be just address. So this is an address, operand address. So this is where it's going to actually jump. All right. So here we have I as an actual instruction pointer. So we'll have to implement instruction pointer that actually respects the jump operation, I think. To be fair, Zozin, have you solved the halting problem yet? Yes, I already solved it. I think it would be quite nice to have instruction pointer as the part of the machine. What do you guys think? Is that a good idea to have instruction pointer as the part of the machine or not? Because instruction modifies the state of the machine. So that means we have an instruction that modifies instruction pointer, which means the instruction pointer is the part of the machine. And what's interesting is that the address for instruction pointer is a word. That means the instruction pointer has to be word as well. This is Lisp, not assembly. I mean, it's a virtual machine for the Lisp. And stack pointer to instead of stack size. Well, that's a good point. I will keep that at the back of my head, X layer 7. But right now I'm gonna just implement as I implementing it right now. But you know, stack pointer is actually a pretty good idea. Yeah. Yeah, I think it's actually a pretty cool idea. So what's going to be the halting state? What's going to be the halting state? I guess the halting state is going to be when you're actually hitting an invalid address, at least for now. Or maybe we're going to have an instruction, a special instruction for halting, right? Inst halt, right? If you hit that instruction, the machine should actually stop. Does the stack grow dramatically? No, it doesn't grow dynamically right now, and this is exactly what I said at the beginning of the stream, and I only started to implement it. Where have you been? Katul, like every time I read your message, Katul, it feels like you're just trolling me. Are you doing that intentionally? Because we discussed that. It's really strange how every time I read your message, it feels like you're literally trolling me. Kinda sus, not gonna lie. Kinda sus. Alright, so let's continue. So we have a halt, and since the machine can be halted, so maybe we're gonna have like a boolean, and it's gonna be halt 0. I think it's then second, maybe, I don't know. But why not dynamic step? It's a good question, and this is because I started to develop this machine 1.5 hours ago, literally. So 1.5 hours ago, we didn't have these 172 lines of code. We literally had nothing. So I'm just in the middle of the designing this entire thing. Sorry, I have bad connection. Oh, okay, very well then. I just didn't know that you have a bad connection, so Everything's okay now. A line per minute. Yes, it's actually pretty good performance in enterprise environment. Am I right? Anyways, so the way we're gonna do all that. So we start at 0, right? We start at 0. And instead of doing this thing, what we have to do while BM is not halted, right? While BM is not halted, we're gonna try to execute an instruction, right? We're gonna try to execute an instruction. So we execute an instruction, then we print the state, and so on and so forth. And what's funny is that we executing an instruction from BM IP, right? Instead of I, we're using BM IP, which is an instruction pointer, right? So that's what we're doing here. What is the purpose of a language VM? So, for example, if you have an interpreted language, you basically translate the IST of your interpreted language to that virtual machine, and instead of interpreting AST, you interpret the bytecode. And what the benefits I see is that it's probably going to be a little bit faster because you don't do, like, you know, separate function calls. You just go through the instructions linearly and interpret them. And another benefit I see is that if the bytecode is very close to the platform you're interpreting this thing on, you can quite easily implement just-in-time compiler that translates that bytecode to your native code, and it's going to be even more faster. Is it like in the case Lisp gets converted to machine code for coding so on virtual machine? Yeah, very much. And then that code gets translated to, yeah, exactly. Is a language VM just a normal program, zoomer in programming? Well, anything that executes on your computer is just a normal program. So I guess yes, like literally everything that you do on your computer, it's just a normal program, whatever that is. Because otherwise it won't be able to execute on your computer. It's that simple. As a matter of fact, we cannot execute anything on our computers but normal programs. So I don't know what the question is all about, to be fair. Will we make a JIT? Yes, I do have plans to make a JIT, but not right now. First, we need to implement the virtual machine that is usable. All right. So we're going to have JIT. Maybe we're also going to have AOT. Who knows? So actually, AOT is going to be even better. So essentially, interpreter before starting up, it will load up the AST, translate it to virtual machine bytecode, and then it will translate it to machine code and only then execute it. So why not do AOT? We'll see. I don't know. We don't have enough information. Now that you have a virtual, I don't have a virtual machine yet. I only started to develop 1 and 41 minutes ago, 1 hour and 41 minutes ago. I don't have anything yet. What are you guys talking about? I literally just started developing this thing. Okay, everyone calm down. We need to continue developing this stuff. We need to continue developing things, right? It's too early to celebrate the virtual machine. Oh, there we go. Okay, cool. So what are we doing? People are too excited. Yeah, I can see that. We haven't implemented anything. People already assume that I have like actual virtual machine. I have actual JIT, and I have to actually put it on Reddit and form upvotes. That's probably what people think. But no, I just started implementing it. Calm down, everyone. Calm down. We're gonna have everything eventually. Okay, so here's the jump, and it's gonna be return. And it's jump. Can you make a BM inside BM? Sounds like an interesting idea, maybe. We'll see. We'll see. But we have not implemented BM yet. Look, chat. Can your Vim do that? Can your Vim do that? I don't think so. No, I don't think so. Haha. Alright, so what else do we have here? We also need some other stuff. So we have a jump. And another thing I need to implement is probably halt, right? Oh, by the way, this is actually not jump, it's GMP. And then I can do something like halt. There we go, there we go. So another thing I can try to do something like, Can I? Oh shit! A line? Can I do it like that? Yeah, there you go. Can you even do that? I don't think so. Halt. Don't worry about it. Don't worry about misspelling. I'm programming in statically typed compiled language called C, and you know what that means? PS comp sci. That means if I made any typos, they're gonna be caught by the compiler before any catastrophic events will happen. Don't worry about that. We're not programming in JavaScript or Python, where before you can catch this kind of errors, the program will execute so many side effects it's impossible to revert them, right? We're programming in a real programming language with statically typed system, okay? Don't worry about that. Oh, you see, we caught it. We caught it. Look at that. And now I fix it, and the program didn't do any harm. The program didn't do any harm. All right, let's continue. So, so what do we have here? So every time we execute any of these instructions, I think we have to increment IP. So IP plus 1. So, and it's kind of like a lot of work that I have to copy paste this kind of stuff here, but I think maybe that's okay. BM IP plus 1. All right, BM IP plus 1, and then BM IP plus 1. All right, so let's take a look at other stuff. So we still don't handle inst jump, and this is quite important. Okay, so we're going to implement instruction jump. So instruction jump, and this is quite important. If inst operand is not a valid address, right? If, for example, operand is less than 0, or the operand is greater, to be fair, that's actually interesting. So that kind of assumes that the program has to be also part of the... That is very interesting. It kind of assumes that the program also has to be part of the machine, because we need to know whether we're trying to jump to an incorrect address or not. And that should generate an error. So as you can see here, it's actually very interesting. The program is outside of the virtual machine, but to function properly, it needs to be inside of the virtual machine. So what that means, we have to bring it inside. Isn't that interesting, chat? Isn't that interesting? I think it's kind of interesting. So let's actually find the virtual machine. Yeah, here it is. So we actually bring more and more things into the virtual machine. It's quite fascinating. Maybe you can make it a one name and... No, for the security reasons, I kind of want to separate data, stack, and program into separate non-intersecting sections, memory sections. And what's funny is that this is exactly what WASM does. Right, the stack of the program, the memory of the program, and the program itself are in completely different, inaccessible like parts, non-intersecting ones. But to be fair, that makes it less useful because you cannot create polymorphic programs. We can try to experiment with one name and architecture, but I don't know. So how many like polymorphic, like useful polymorphic programs do we know? Except viruses and DRMs that nobody likes anyway. How will what is polymorphic? That means the program modifies itself during execution. That's what it means. Imagine a program that has an access to its own code, and while executed, it also modifies itself and executes again and modifies itself, executes again, and so on and so forth. It's actually quite close to Quines, I think. Crack me isn't, yeah. Anyway, so in our architecture, self-modification won't be possible. If you plan on writing a JIT, might as well plan ahead. Okay, thank you. That's a very useful advice, I suppose. Anyways. So we're gonna have here, we're gonna have a bunch of instructions. So we're gonna have a program, and we're gonna have a BM program capacity, right? And then we're gonna have size program size, right? So this is what we're gonna have here. And to be fair, I want to kind of put, oh, instruction pointer is actually related to the program, so we're gonna keep it here. Okay, but because of that, I cannot easily create something like this. So that means I need a way to push an instruction into BM. So let's actually implement something like this. We're gonna have BM inst push inst, right? Push inst. So this thing will accept a pointer to BM and instruction that you want to push into BM, and it's literally gonna just push it into BM. So it's gonna be a program, BM program size, plus of course, and we just assign an instruction there. But we also need to check something. We're gonna assert that program size is less than BM program capacity. Personal question, you don't have to answer how much is rent on average in your area. I can tell you, I think. So wait a second, what's the it's around 220 bucks, around like this. So is that a good rate? A month. So this is monthly. Too good. Well, trust me. Like, if you are you from Russia, by the way? If you're not from Russia, like, it doesn't really mean anything. If you're not from Russia, I don't recommend living in Russia. So don't, if you're not Russian, don't move to Russia just because of the rent prices, okay? So just for the record, because it's literally, I'm just curious. Okay, so just for your information, Russia is like technically third world country. You don't really want to live here, okay? So just because the price for the apartment here is so low, it doesn't mean that it's really comfortable to live here, okay? So how much is heating on minus 25 Celsius? I usually pay like, I don't know heating specifically, I pay for like everything at once. It's electricity, heating and water and hot water and stuff like that. It's usually around, let me calculate, 15 bucks. Anyways, so I'm telling you, the only reason why I'm doing streaming full time is because I live in a shithole. So don't think that I somehow earn a lot of money and that's why I'm doing that full time. No. I actually earn like around like a McDonald's cashier in Novosibirsk. But because I live in a shithole and actually live a very minimalistic lifestyle, right? I don't really spend that much money. I'm able to afford to do that full time. If I, for example, were to move to Moscow, I would have to abandon this entire project completely. I would have to stop streaming completely because I would have to find a job because the price of living in Moscow is fucking ridiculous, right? So yeah, it is what it is. Don't think that I'm somehow like some sort of like a rich streamer or not. I'm actually pretty poor. So anyway, whatever, it doesn't matter. I do what I like. I'm developing a virtual machine. Yeah, what else could I ask for? I have my cup of tea. I'm developing my virtual machine. I'm enjoying what I'm doing. It's fun life. All right. So let's continue. So now I want to be able to push the instruction, and there we go. So it looks quite good. So what we're doing here is, before executing anything, I'll have to push. Yeah, you don't have to. Thank you. You didn't have to. I'm actually quite okay this month. So thank you so much for $69. Thank you. Really appreciate it. Thank you. BM push inst, and I'm gonna just put it like that. There we go. So what I want to do here is query replace that with that. No, it was actually kind of dangerous. So I need to query replace that. I need to use query replace regular expressions. That with that. Boom. There we go. So this is how we're gonna initialize the program from now on, right? So we're gonna literally push instructions into the program. Couldn't you mem copy an array into BM instead of? It's actually a pretty good idea. Thank you. That's why I'm poor and you are not, Gia. So. Okay, that's actually a very good idea. Thank you so much. Okay, so we can do a mem copy. So we'll have to actually set. To be fair, we can do something like this. We can even have a function bm load program from memory. Isn't that cool? Load program from memory. I live in Bosnia. That is next level of shithole. So good. Yeah. No, I'm not saying that there are worse places. I'm actually kind of in a sweet spot. To be fair, it's kind of a shithole, but it's not that much of a shithole that it's impossible to do anything in here. Like, I still can have an internet. I still can stream. So. It's not that bad. Like I kind of found like a sweet spot. You're channeling the John Blow names now. Oh, I see. Well, I mean, this is what this function does. It loads a program for memory because maybe what's going to be the next logical step, chat? What's going to be the next logical step? Isn't that interesting? That's already starts to get very interesting. So, So, but first we need to actually learn how to load that from memory. Does it really need? Well, it does need because C doesn't have namespaces. Yeah. So in C++ I would just create a namespace, but in C, too bad we don't have namespaces. We have to prefix everything. You have 25 days of experience of loading from. God damn. Anyway, so yeah, I do. I'm proud of it. Okay, so we're gonna have a instructions. Here's the program, and then we're gonna have a program size, right? So we need to know the program size, and it's basically instruction count. Yeah, that 21st day definitely was an experience. Yeah. Alrighty. So might as well actually maybe put things somewhere here. I can read the file in 25 different languages. Yeah, I can. I'm not gonna lie. Okay, good. Oh, by the way, do I even have BM program capacity? I don't have a BM program capacity. What kind of capacity we're gonna have? 124, for now, at least. Dump, yes. We're definitely gonna have a dump to program. We're gonna have everything. Don't worry about that. So, yeah. So we're also going to have an assert that program size is less than BM program capacity. That's quite important. So and then we're going to do memcopy. So BM program, this is the destination of our nation, and the source is going to be program. And how many bytes we want to copy? We want to copy program 0 multiplied by program size. There we go. So this is how many we copy. then program size equal to program size, and we are Gucci, we are Tamaguchi. So afterwards, I'm gonna do a program, load program from memory is gonna be BM, and I do program array size program. There we go. So we loaded everything. So then we're gonna dump. I think this function should be called not just dump, but rather dump stack. I think that makes more sense because we're only dumping a stack. We don't really need to dump everything. Okay. So now, what we're gonna do? We can actually change execute instruction to accept only the virtual machine, I think. Right, and now we execute an instruction, we dump the stack, and we check if we hit an error or not. And we keep doing that while we don't halt, right, while we don't halt. Right, makes sense, makes sense? Okay, so I think we're ready to try to build this entire stuff and go through the compilation errors. So we don't have inst here. Let me find inst definition. I think it's defined somewhere here. Yeah, so essentially it has to be defined before the machine itself. Somewhere here, I would even say. Maybe even somewhere here. Boom. I feel personally attacked in my lang design choices. Good. I'm joking, yeah, it's okay. So what we're gonna do here, so we can do the following thing. If BMIP is less than 0 or BMIP is greater than BM program, actually in program capacity, but BM program size, we'll have to return error. It's not really illegal instruction. In our case, it's actually seg fault. It's literally seg fault if you think about it. Segmentation fault. It's rather illegal instruction access. Yeah, it's rather illegal instruction access. It's not an illegal instruction by itself. It's an illegal... well, exactly. That's why I didn't want to call it segmentation fault, right? So, because it doesn't really have any segments, but we need to call this error somehow. I think it's illegal instruction access. I think it's a good one. Alright, so it's an illegal instruction access, and we're gonna put it here. So, bruh. Yes. Illegal instruction access. Okay. It's less than that, or actually equal as well, because it could be equal. Cool. So, and after that, we're gonna do the following thing where we take inst, and it's gonna be BM program BM IP, right? So we take that and we try to execute all of that, and then we increment IP. But in case of a jump, right? Now the time has come to implement the jump, I suppose. Okay, so we also have additional error that we need to add to this situation case. Right, and we're gonna return this thing here. Okay. Okay. So comparison integer. Oh, okay. Program size. Okay, since we're comparing them, I think there also have to be a word. At least for now. At least for now, they're gonna be words. Okay, so this is A. What else do we have here? So we don't handle a jump. Right, so the time has come to implement the jump instruction. Right, it's going to be inst jump. And you know what? I think we can literally just do the following thing. BM IP equal inst operand. Right. And if we're jumping to an illegal address in memory, it's going to be caught on the next instruction. You will try to execute the next instruction, and this is going to be checked automatically, and there you go. You have an illegal instruction access. So I think we can just literally just jump there and forget about it. Do you have a work other than Twitch? I don't have any other work, and I don't work for Twitch. In my contract with Twitch, it is explicitly said that I cannot claim that I work for Twitch. I don't work for Twitch, sorry. Okay, so we need to implement halt, and the halt is quite simple, not gonna lie. You just do halt 1. Cool. So what we're doing here, this one has to be a word. Do we have anything else? Implicit declaration on mem copy. I think you have to include string to be able to do that. And finally, this thing compiles. All right, so what we're gonna do here, I have an idea. We're gonna add, we're gonna do make push, and we're gonna put 0 there, and then we're gonna add another one, which is gonna be 1, right? Which is gonna be 1, and then we're gonna do make instruction plus, and then we're gonna do make instruction jump, and we're gonna jump. So this is a 0, 1, 2, 3, and I'm gonna jump to 1, right? So I'm gonna loop all of that. But you can say that it's kind of dangerous, and I agree with you. So what we can do here is basically limit how many instructions we can make. So execution limit, bm execution limit, plus I, and let's quickly define this thing. We're gonna remove it at the end. I just keep it here for the testing purposes. Okay, so let's compile everything. There we go. So it looks good to me. And if I try to run bm, I did it actually incorrectly. There we go. So yeah, essentially what it does, it just pushes 0, 1 on the stack and keeps incrementing the value on the stack. It pushes 1 on the stack and keeps incrementing. Pushes 1, incrementing, pushes 1, and there you go. And it just keeps growing. Right, so now we officially have loops. Chat, think about it. We officially have loops, but we don't have conditions. We don't have conditions. How are we going to implement conditions?
Собака цудинг стоп бин курпиелес собака анонymушери ричил вент шьюту адьюил матертракер.
Thank you, Arch. Thank you, Arch, for 5,000 bits. Holy fuck, I think it's $50. Thank you so much. Thank you. I'm not a PHP developer, but $50 is $50. I'm not gonna lie. I have nothing to say. Like, I would try to stop being poor, but I don't think I'm that poor, to be fair. Like, I would probably say I have some skills that you cannot buy for money, so which makes me a little bit rich, but it's not that many. Like, how to say that? Okay, maybe I am poor. I don't have that many interesting skills anyway. I can just type shit into the screen and make a computer do things. Like, everyone can do that in 2020, am I right? So being a programmer in 2020 is not that impressive. Like, anyone can be a programmer these days. So I don't think I have exceptional skills, but thank you so much. Typing shit into the screen, yes, I can do that. That's exceptional skill. You would be surprised how many people can do that in 2020. Maybe. Anonymous cheer. Holy fuck. Thank you so much for $60. Thank you. I don't know who you are, but I really appreciate your support. Okay. So, and while Anonymous Chair and Archelesis are dueling with each other, let's continue with our virtual machine. Right, let's continue with our virtual machine. So to implement conditions, we basically need a jump, but conditional jump. So I'm gonna create yet another instruction, but that instruction is gonna be actually called jump if. Guess what this instruction is gonna do? Who's gonna guess what this instruction does? It will... nah, it's not gonna be with flags. We don't have any flags. We don't have any flags. It's Jiang is actually the closest. It's jump if true. So essentially, it will look at the top of your stack, and if the stack, it will consume the frame of your stack. It's JNZ, yeah, it's closer to JNZ. So, and if on the stack the value is not equal to 0, it will jump to a specific address. So, and we're gonna have other operations like inst equal, right? And maybe even inst CMP, not inst CMP, I think equal, we're gonna have GT, JE, and so on and so forth. We're gonna implement them later. I might actually implement EQ right now, right? Which basically, yeah, I'll probably need a pop as well. I'll probably also need something like dupe that duplicates the elements and stuff like that. Also, I wanna have a random access to the stack, because sometimes you want to like get a value from the bottom of the stack. So it could be something like yeah, some push for ROM that accepts an address in the stack. Yeah, it's gonna be a stack machine from the with the random access. Yeah, because sometimes like you may have something like this on the stack and you need to access this element, and it's actually quite pain in the ass without any registers to access. So I'll have to either add registers or a random access to the stack. So we'll see how it goes. I will see what's going to be the more convenient way to do that. It's like a fourth. Fourth is essentially virtual machine. It's essentially virtual machine. Any tips for Emacs? Don't use it. If you never used Emacs, don't use it. If you already use Emacs, well, too bad. What is the difference between ROM and SSD? Well, the Levenstein distance between their names is actually 3. I'm so sorry. Anyway, let's continue. So, okay, so how can we build this shit? Okay, so we're gonna have a jump if. We actually need jump if and halt. Jump if. Was Emacs easy for 1 year? Then I went to Nervim. Stay on Nervim. As a 10+ year experienced Emaxer, I give you advice: don't fucking use Emacs. Seriously, don't use it, please. Don't repeat my mistakes. Okay, don't repeat my mistakes. Keep using NeoVim. It's a good text editor. It's a good text editor. Trust me. It's a very good text editor. Not even joking. Okay, rejects. Align rejects. I have a really sore throat. I think I'm gonna be sick soon. I'm pretty sure I'm gonna be sick soon. It's too cold in here. Can do nothing about that. So this is a halt, but I didn't want halt, I wanted EQ, actually. Okay, so here's another thing. So we need to implement EQ.
Собака цудин квисус я never курфился кейман собака аноним ушери рае муитинг.
Thank you.
Матертракер капа.
Cock Thank you, Arch, for 5,000 bits. Thank you. Well, 10,000 apparently. It's still 10,000. Thank you. I guess it's $100, I suppose. Ford, your message actually got me. Thank you so much. All right. So let's continue. Cock and throat. All right. So what we need to implement? We need to implement inst eq, and now this won't stream for a month. I actually was streaming when I had. I think I was even streaming when I had corona. Well, I mean, I had corona allegedly. I actually never. It was actually never confirmed, but I was sick, and all of the syndromes were corona syndromes actually. So and it still was even streaming even then. So I don't think just like a simple cold will stop me from streaming. Yeah. Could you smell? No, I couldn't smell and taste. It was so weird. Holy fuck. Yeah, I will still have some. Don't worry about it. You had a chance to give us corona. Yeah, I'm sorry. I wasn't wearing a mask when I was streaming, so sorry. Okay, so what we need to do here, by the way, we need to implement the equality operation, right? We need to implement the equality. AOC effect. Well, it's actually was way before AOC, so it was definitely way before AOC. I'm wondering, even though it's a common practice, why not just straight up emit x86 assembly instead of doing VM? Because it's actually more cross-platform. Thank you, Anonymous Chair, for, I guess, this time 14, so it was 6, and this is 7, so 12, 13. 13,000 cheers. Yeah, it's 13,000 cheers. Thank you so much. I've nothing to say, like, thank you, Masters, by the way, as well. Do I need to do anything or say anything? Because I'm just here to develop a virtual machine. Like, I just want to develop a virtual machine. But thank you so much for supporting the channel. You didn't really have to, because I'm okay for this month. Like, I wasn't like a week ago, but I think I think now I'm okay for the month, so I don't really need much anymore. Time to install Zig. Did we reach 300 bucks? No, somebody has to specifically donate 300 bucks, like specifically for the Zig. No, it has to be like that. No, I'm not accepting anything but that. Alright, so what we need to do here, we actually need to do this thing equal to that thing, and this is how we do equality, right? Another thing we need to do, another thing we need to do. I'm not donating for the Zig, by the way, anyway, so you don't have to do any of that. Nice, thank you so much. Okay, so let's do jump if, right? We are finally implementing jump if, conditional jump. So what we're gonna do here, we're gonna take the, well, we have to first check if we have enough operands for that, right? So stack size has to be, if it's less than 1, this is straight up stack underflow, right? This is a straight up stack underflow. Somebody has a thing about with stream Zig, I donate $3 to negate the donation. That's an interesting approach, but I don't mind, I guess. I'm gonna be totally okay. So yeah, if you don't like Zig and somebody donates $300, you can donate another $300 to actually cancel that decision. Yes, it is a thing. Yes, I'm totally okay with that. Go ahead and do that. All right. So let's continue. But I mean, who's gonna donate $300 for Zig? I mean, it's probably very hardcore and rich fan of Zig. You can donate to yourself to, yeah. With the same $300, I just donated to myself. Yeah, no, nice one. Anyway, so if the top of the stack is true, what we're doing, first of all, we are decreasing the stack size, and we're setting the IP to the instruction operand. We're setting the IP to instruction operand, And I guess that's it. But otherwise, if it's not, we're just incrementing the IP. So this is going to be the approach that we're taking. All right, and all of that compiles. We have conditions. So technically, our virtual machine is Turing complete. Well, it's not Turing complete, it has a limited memory, but still, you can now try to calculate Fibonacci numbers in it. We can actually have a debug instruction debug, right? So instruction debug, let's call it print debug. It's essentially gonna print the top of the stack, so it will print the current number and pop it out of the stack. So it's gonna be purely used for debugging purposes. So and I think the first program that I want to write a generator of Fibonacci numbers. That's what I want to write. So it's going to be print debug, and then later we're going to actually remove this instruction. But for now, I think it's going to be kind of useful. So it's going to be a line regex. It's going to be returned. There we go. Do we need to do anything else here? So here's another thing. So let's fucking do this. Debug, print debug. So we need at least one frame on the stack to print anything. We need at least one thing. Okay. So printf. So we're gonna just print this thing. It's gonna be bm stack bm stack size -1, right? IP is set to an operand in num value, but also a pointer. Is that right? I don't know. The operand is an address. Yes, the operand is in address. So that's it. So, and this is a condition. An operand is not in a num, it's a word. I'm not sure what you mean, I'm sorry. Okay, so we also have to pop out this thing from the stack and continue the execution. So it's going to be IP +1. How about inst dump stack? We already have that, but not in the form of the instruction, I think. So does it have to be LD? Yeah. Oh, there we go. Okay. So let's try to compute Fibonacci numbers. How about that? How about that? So how can we compute them? How we compute them? So we have to push first two Fibonacci numbers onto. Oh my god. Okay, onto the stack, right? So then I kind of want to actually. So what I want to do? Let me think. So we push them, but if I sum them up, I will lose the previous one. I will lose the previous one. To be fair, maybe we need to implement an instruction. Maybe we need to implement an instruction that allows us to access. Well, dupe is a very specific instruction, but I think we can actually make a more general instruction that accesses the stack arbitrarily. Archelesis, holy fuck, thank you so much for 20 tier 1 subs. Thank you. And everyone who got a sub, welcome. Alright. I don't know what to say. Thank you, I guess. I'm gonna try to be cool and ignore that. Like, it's nothing. It's just 20 subs. Thank you so much. Anyways. So essentially, I kind of want to have an instruction that access the element with an address, but a relative address, relative to the top of the stack. You see what I mean? So if you have the stack and the top is here, so here's the top, you would be able to push, for example, 0. If you push 0, you push the current element, effectively duplicating it. If you push 1, you push the previous one, like this. If you push 2, you push the previous. So you see, it's relative. So I want to push, but a relative. Or maybe dupe relative. Yes, dupe relative. Sodium will soon be able to afford a VTuber avatar. You are that person with 80 premium listening headphones by Audio Technica. Are they premium? I don't think they're premium. It's just they're actually kind of average, aren't they? I don't know. I wouldn't say. Holy shit! 25 subs. It's whatever. Thank you so much. You know, the 25, nothing special. Okay, just thank you for your small help. Guys, can I just develop virtual machine? I just want to develop a virtual machine, please. I'm okay for this month. Really, I'm okay for this month. I will be able to pay rent. Shade 3 TV, thank you so much for 5 subs. I have everything, like I did the groceries today. I stock up for 3 days, so I don't have to go anywhere for 3 days. I'm okay, really. Like, you don't have to. Like, everything is okay already. Thank you so much. So I want to implement another instruction, dupe. Okay, dupe. But that dupe is gonna be not a forced dupe. It's also gonna accept the position relative to the stack from where to take the element and from where to duplicate the element. So, and let's actually do that. I think it's gonna be pretty useful instruction in my opinion. So I'm gonna put it somewhere here. It's gonna be inst dupe, and what it does, it also accepts the argument, or rather a relative address. So let's put it like that, dupe, and there we go. Let's try to compile that, and here, okay, we don't have that. It's gonna be case inst dupe, return inst dupe. Okay, cool. So now we have this kind of stuff, and now we need to interpret the dupe, right? Kin inst dupe. All right. How are we gonna do all of that? Super Kali subscribed with Twitch Prime. Thank you for subscribing to Twitch Prime, and welcome to our epic virtual machine club. A virtual machine club, I would even say. A virtual machine club. All right. So how are we gonna test all of that? I suppose if an instruction operand is 0, that means we need to get that one, right? So bm stack size minus operand. So this is how many of them we have to have. So I need to visualize the stack. It's 1, 2, 3, 4. All right, and so size essentially like points here, right? And if you subtract an operand, right, 0 is going to point here. So if you want to do 0, 1, 2, 3, if you're going to do 4, right? Okay, so that means if this thing is less or equal than 0, that means you basically hit stack underflow. Maybe you should abstract generalize random stack access to not check for stack underflow every instruction. Probably, but this is not the problem that I'm solving right now. All right, so. Oh, I see what you mean. So essentially, like basically get stack frame. Is that what you mean? We can try. Yeah. No. I see what you mean. I just couldn't understand what you're trying to say. So, okay. So we can do something like error bm get stack frame. You accept bm, actually const bm, and you can try to get the index. All right. So try to get it by index. Maybe like a specific address or something, and it will return you either okay or overflow or underflow. It's actually will require to rewrite everything. Macro for dupe, really? Oh shit. Okay. Thank you. So okay. So let's implement that. It has to be that, so it's going to be return error stack underflow. So, and what's interesting is that operand can be negative. I think not inst operand. If operand is less than 0, I think this is illegal instruction. But the legal instruction for instruction that is not known, maybe we can do something like illegal operand. Yeah, it's going to be illegal operand, and we'll have to add that error there, but a little bit later. So, okay, and what we do here, we do stack bm stack size -1 minus inst operand. Right, so if it's 0, it's going to be the top of the stack, and we push that essentially on top of the stack. So it has to be something like this, I suppose. Right, and another interesting thing, I think, if bm, so stack overflow. If stack is already that, we also have to check for stack overflow here. So that's quite important. Maybe we will abstract these things away, but yeah. So first we check for stack overflow, stack underflow, illegal operand, and there you go, we do this thing here. Then stack size, we increment that, and then we also have to increment IP by that. Cool. So now, will that compile? It will not, because we don't have this error yet. So let's introduce this error. It's going to be something like this. So we have a lot of different errors here already, but it looks okay so far. So, and we also need to add that error somewhere here. It's going to be error illegal operand return error illegal operand. There we go. Cool. It does in fact compile. So essentially what I want to do here, I want to now go make instruction duplicate, but I want to duplicate not the top, but actually the one below, right? The one below. So after that, I just need to sum them up. And that should be it, I think. That should be it, and that will slowly generate the values on top of the stack. So basically, it will fill up the stack with the Fibonacci numbers. I think it's gonna be quite cool. So this is 3, and I think we can just do inst jump, right? Inst jump. And where are we gonna jump? We're gonna jump to 2, right? We're gonna jump to 2, and this is a simple Fibonacci number generator which generates them indefinitely, right? It's literally 5 instructions, right? So what we're gonna do here, I'm gonna actually dump the stack after the execution, and we're gonna only execute 69 instructions. We're executing 69 instructions. We can actually execute 69 instructions multiplied by array size of program. So maybe, because I want to like, yeah, let's actually do like 69 times, and we'll see what we're gonna get. All right, so if I try to execute that, and that didn't work at all. That's really interesting. I wonder why. So if I do something like this, so I'm gonna execute only first instruction. Okay, so the first instruction pushed. Okay, that makes sense. So I can remove that. So this is the one single instruction. It pushed 0. So if I have two instructions, it pushed 1. Okay, so it was 0, there was 1. What about 3 instructions? It duplicated the previous element. Okay, so what about 4? So it should actually sum up. Okay. That makes sense. I see. Okay, so we actually have to duplicate two of them. So we're gonna duplicate 0 and 1. Okay, so that means this is 3, 4, and 5. I wish we had like relative jumps, but we can only have absolute jumps, right? So we'll have to still jump to 2, which is okay. All right, so I'm literally like programming in assembly of my language. Oh, I see. Oh, this one is interesting. So that means this has to be 0 and this has to be 2. Huh. Okay, that's cool. And then you sum them up. All right, cool. I think I fixed it. So, and if you start going to a different place, there we go. Dupe 1, dupe 1. Oh, that's actually a good point. Huh, yeah. That's a good point. All right. So let's execute this stuff 69 times now. 69. Let's see what's going to happen. Okay. So as you can see, it generates Fibonacci numbers. So yeah, we have a virtual machine and we have a program for the virtual machine that generates Fibonacci numbers. That's actually pretty cool. Hello, Columbetka, welcome to the stream. Can you non-stack based language do that? Yeah, it's, what the fuck, why is it so cool? That's actually so nice. Yeah, and I like this dupe, by the way. This dupe is actually super useful. Yeah. Nice. Okay, so another interesting thing. Do you like concatenative languages? What are concatenative languages? Like Forth or something? Masters, by the way, thank you for 69 bits. Thank you. Okay, so can we now dump a program to a memory? So speaking of, right. So maybe we're gonna have a special representation for programs, like bytecodes. Yeah, like Forth. I programmed in some of them. To be fair, it's kind of difficult to write like big projects in concatenative languages, unfortunately. But they're quite good for low-level development, I think. Save program to file. So what we're gonna have here is a program pointer to instructions and the size of the program. So it's gonna be program size. And yeah, we also need to provide the file. We might as well actually do something like, yeah, file path. Let's accept file path. But can it run Doom? Well, we only started developing this thing. File path. Alrighty, so let's go. We're gonna just dump the whole program there. On top of that, I wanna have an assembly for this virtual machine as well, right? So where I could like literally write something like this. Let me try. Let's do fib, and it's gonna be bm right, fibbm, where I could do push 0, push 1, dupe 1, dupe 1, plus jump. Let's put something like this. Is gonna be like begin, jump, begin, something like this. So I want to have something like this here. Yeah. So, and that will translate to our thingy. It buzz. It buzz. Oh fuck. Archelasis, I hope it's not for Zig. Thank you. Thank you so much. For 100 bucks. Thank you. I really appreciate it. Okay, I guess I just have to ignore it. Like, I was asked to ignore 100 bucks for 100 bucks, and that's what I do. Well, that's what I'll have to do. Okay. You didn't continue as nothing. I'm sorry, but yeah. So, okay, if I do something like Nazem. Okay, thank you. Thank you so much, Masters, by the way. Alright. So I think, god damn it, I think it's quite easy to implement something like that. I implement like the parser for this language. So basically you just, yeah, I think it's relatively easy. But you have to keep track of the lines and shit. Maybe for now, we can implement something like just this. So what is this line? This is 1, 2, this is 0, 1, 2, and just 2. Anonymous, sure, with another 100 bucks. Could you guys please stop? Like, I don't need any more. Well, thank you. It's not like I don't appreciate it, it's just like you're literally wasting your money. Like, seriously, at this point you're just wasting them. Come on. Thank you so much. I'm good for this month. I'm good for this month. Thank you. Let's just have fun and develop a virtual machine. Okay, so come on, let's just have fun. So for example, let's think how can we parse such assembly and stuff and generate stuff. All right, so first of all, I want to be able to save the program to file. Let me see. So it's going to be file F open. So it's going to be file path, and we open it for writing in binary mode. It's quite important to do that in binary mode, right? If F is null, right, that means an error has happened and we have to report it. So it has to be std error could not open file. We're going to provide the file path and also the description of this thing as well. Thank you, Masters, by the way. Thank you. And we're gonna have str error null, right? And then we're gonna exit with 1, indicating that the error has happened, right? Lambakota, what's up? How are you doing? Welcome. Right, and I think we're gonna write. We're gonna f-write. Okay, so we're gonna take this thing. There we go. So the pointer is the buffer, right? It's going to be the program buffer. So the size is the size of a single element. It's going to be size of a single instruction, and then the count, program size. There we go. And we're saving all of that to here, right? So something like this. So then we need to check if an error has happened while doing all of that. And in that case, we have to, you know, do it like this. There we go. So could not write to file. There we go. So and after that, we could save all of this. There we go. We have a function that basically dumps the program to the Oh, we don't even have to the file system. So we need something like error no, and there we go. Now I say accidentally saved compilation mode. It's kind of strange, but yeah. And let's remove that. So cool. Now if I try to dump this entire thing, I'm gonna actually do it like this. Int main /n becomes /r on window, and the text mode also still. Oh, you explaining what's the point of the binary mode? Yeah, I see. Thank you so much. Thank you. All right, so pm save program to file. We provide the program and the size of the program, and we save it to what we're gonna save it to. I think this is gonna be ebosm, and the files with the binary code is gonna be fib bm. So this is gonna be a bm files. Right, so let's actually try to run it and execute it, and we have a bm file, and this is the binary code. We can take a look at hexel mode, and well, it's actually pretty simple. What's the size of a single instruction, actually? 96, not even 69, would you look at that? Not even 69, 96. Yep. Okay. Alrighty, so maybe instructions are too long, but they shouldn't be. So the size of the instruction, I would presume, is something like, well, 64. Yeah, it's kind of strange, like it's kind of uneven, but maybe we can fix it up a little bit later. In any case, we need to implement load program from file. That's what we need to implement. We need to implement load program from file. So we can implement a load program from memory. So let's do the same but from file. bm load program from file. It's log 20 gigabyte. Okay. bm. Yeah, we're gonna load it into the virtual machine memory. So, and we're going to provide a const char file path. There we go. So the idea is going to be actually slurping the whole file into the memory and then calling bm load program from memory. That's going to be the idea. Does it sound good? If you save a text element, you have to reparse probably. All right. So let's do fopen. Open read in binary. Actually no, it has to be file path. Read in binary, and if file equal to null, well, too bad. We'll have to indicate that an error has happened. So also let's close the file afterwards. We now also need to figure out the size of the file, so we have to use something like fseek, right? Let's see, the usual stuff. Fseek. So the file is going to be the offset is going to be 0, and I think it's something like seek end, right? Seek end. So it puts the cursor at the end of this entire thing. And we can check if this entire thing is actually less than 0. I think it returns like -1 in case of an error. Yeah, it returns -1 in case of an error, and in that case we have to indicate an error as well. So this one is going to be could not read file. Right. And after we did that, we have to do ftell, which gives us the position of the cursor, right? And this is going to be our file size. And I think ftell also returns -1 on an error, right? We have to be really careful, but it returns long. All right, if m is that, we'll also have to say something like this. We couldn't read that because it doesn't really matter why. That means we couldn't read that. Okay, so then we need to allocate some memory. We need to allocate some buffer, right? Let's try to allocate some buffer. So it's gonna be something like, oh, it's quite important actually. I think we need to assert that m is divisible by the size of the instruction. That's quite important. Actually, by size of bm program 0, because we can change the type at any moment. It's better to depend on this kind of stuff, right? If it's divisible by that value, if it's not, there's something incorrect here. So it's quite important that it's that. So then we can try to maybe we don't need to allocate anything. Actually, maybe we don't need to allocate anything because we can read into the program buffer like right away. Right, so and another assertion is going to be that m is less or equal bm program capacity multiplied by the size of a single instruction. Right, something like that. What the fuck is going on with this? Am I doing something that dumb, or is that what you're getting me? Anyway, so what I'm thinking is that maybe we shouldn't check for that. Maybe we should check for that. So I was thinking that maybe we can just cut to the capacity, but that will result in unexpected behavior. It's better to oh, okay, I see. All right. Okay. All right. Yeah. So after that, we can be quite safe. We have to actually rewind this entire thing back. So we have to do seek set, and we have to make sure that we did something like this, right? Right. Yeah, there we go. So we said that, and we are ready to do fread. Fread. Okay. So what we're reading here, we're reading into the buffer. So we're reading into the program. The size of a single element is the instruction size here. The instruction size, it's right there. And how many of them are we reading? Well, it's basically m divided by the size of the instruction, I suppose. I think that's what it is. I could have actually abstracted away the size of the instruction somewhere, but I don't know, I'm thinking dumb. x86, if most significant bit address until implement defined limits, not all zeros, GP exception, CPS is basically a zero program situation. This might be interesting for you. Most significant bit of address until defined limits, not all zeros or not all ones, so-called canonical fault, then GP0 exceptions generated. Interesting. Maybe it will be useful at some point, but I'm not sure. We'll see. Thank you, of course. Okay, so and I have to provide the file. So, and that gives me actually how many of them we read. So it's going to be B program size. That's very interesting, actually. All right. So you see what we're doing here? Yeah, because fread returns how many of the elements it's read. So we can use that for that specifically. So, but it could be kind of dangerous, so we have to do ferror. If an error has been generated, that means something went horribly wrong. So we have to fail. Okay, so long unsigned. Okay, that one is very interesting. So I think we can actually make it like as long. Oh, wait a second. So m, we know m is positive here, so that means I can cast it to as size. Perfect. Let me actually not run it. Let me actually not run it, only compile. I want to go through all of these things. Okay. Cool, I think I did it. So now we're actually reading the program from we can read the program from a file. So if I remove a program and I remove load program from memory, it will not produce anything. And if I try to run it, of course, I think it will just illegal instruction access, right? It's literally illegal instruction access because it doesn't have anything. It tries to execute it and it fails miserably. So if we load program from file, it's going to be VM. So what does it accept? Yeah, it accepts only VM and the file path, and we're gonna do. Let's actually suggest an existing program, so it should crash in this case. Yeah, I could not read a file, and it's gonna be something like a fibs bm. And we try to load the program. Fib. It's actually fib bm. And there we go. So as you can see, we don't have this program defined anywhere in the code, and we literally read it from the file and map the file to memory directly, but that wouldn't be cross-platform. So this code right now works even on Windows. If I use mmap, will it work on Windows? Maybe, with some, you know, abstraction layers, but I could have just depended on POSIX and it would be fine. All right, so now we're capable of loading like a dump into a file, which is quite cool. But the thing we need to do, we need to learn how to do this thing. How to do this thing. Anyways, so I think I have not committed anything at all. Are you okay? I'm actually quite okay. Thank you so much. So let's actually extract all of that. The code is affecting. Yeah. I'm gonna make a cup of tea. Does anyone have any questions while I'm making a cup of tea? I remember when implementing a similar thing in AOC, you said, imagine calling this a VM, but now it's actually a VM. Yeah, it is actually a VM. The VM that we were implementing in AOC was not even Turing complete, and that's why we were able to solve the halting problem, because there was not, you know, enough complexity for the VM to actually make it impossible. Right, so it didn't have conditions. But here we have conditions, so it's actually Turing complete. This motherfucker is Turing complete. I'm pretty sure we can even try to implement a game of life in it or something. Or maybe a rule 110 or something like that. Can you recommend some resources to learn how to work with Git? The Pro Git book, create issues correctly. Git and GitHub for beginner. First of all, I can recommend you Pro Git for just generally how to use Git. Yeah, so here's the official book of Git, and check it out. So I recommend you to read first 3 chapters. Yeah, so it looks quite lengthy, but you don't need all of the chapters. Seriously, you don't need them. Read only first 3. Getting started, Git basics, Git branching, and you're good to go specifically with Git. Speaking of how to do GitHub, well, GitHub has like a docs, github.com. You can start from there, right? You can start from there. There's a lot of, you know, tutorials like github.com. Getting started with GitHub, right? So you can actually start from here somewhere. Thank you, Free4. Thank you. So I guess that's what I can recommend you. Also, GitHub is constantly changing, to be fair, right? It's constantly changing. So the best way to maintain your GitHub skill is to be on GitHub all the time and interact with projects on GitHub, participate in open source projects and stuff like that. Make mistakes, learn from your mistakes, listen what people tell you, and so on and so forth. So, yeah. I guess that's the things I can recommend you. Pro Git, first 3 chapters, you don't need everything else, and you know, documentation, official documentation of github.com. So yeah, it is what it is. I guess I hope it's helpful. There's nothing much to say here. All right, so let's make a cup of tea. I want to make a small hello world program, nothing big, just small operating system. What language would you suggest for writing SV and what the fuck is this? Holy fuck, what did I just read? Whew, that was a roller coaster of a message, thank you so much. Okay. Nice one. I can feel how I'm getting sick. Holy fuck. How would you store strings? We can actually introduce something like memory. Like random access memory. And essentially, you would be able to access that random access memory through pointers, and you can push pointers onto the stack. Right. You know what I mean? You know what I mean? So on top of, let's actually go here, right? On top of this here, you're also gonna have a memory, which is gonna be, I don't know, maybe it's gonna be a bunch of words as well, who knows? Maybe chars memory, right? And you're gonna have an instruction, something like alloc 69. And what this instruction does, it allocates you a memory somewhere here and pushes on your stack, the pointer at which it starts, right? And then you're gonna have other operations like, you know, get by pointer, which looks at this stack and looks at the pointer, and so on and so forth. Does it make sense? So, and this is how we're gonna do strings, right? Strings is gonna be just a pointer, like to a memory, and string is located in a memory. I think fourth is doing that in a similar way, I think. Right, and if you like work with strings in fourth, it's actually located in some heap memory and gives you a pointer on your stack, and then you can manipulate the pointers with the stack. But we are not there yet. We are not that advanced yet. We're gonna see how we're gonna implement that a little bit later. So we're gonna have three main things. We're gonna have separate space for the stack of the program. It's quite important. Separate space for the stack. Separate space for the instructions. And separate space for the memory, right? So we're gonna separate these three things. They're not intersecting, they're not in the same memory space for security reasons. Of course, not because I'm lazy, but for the security reasons. Yes, that's how it goes. All right. It's actually similar in WASM, right? In WASM, these three things, stack, program, and memory, are also in separate spaces. They are also not intersecting. All right. Novosibirski kiosk. The fuck? What are you guys talking about? Oh, you're making fun of the name of the city where I live. I see. Okay. Luckily, I actually log everything. Then I'm gonna look at everyone who made fun of the name of the city, and I'm gonna permaban them from this channel. So don't worry about it. Keep doing what you're doing, chat. Keep doing what you're doing. All right. So I'm gonna go to the kitchen. And turn on the kettle. And then I'm gonna go back, and we're gonna implement the. What are we implementing actually? Yeah, we're gonna implement the assembly for this thing. We're gonna implement the assembly. So I think it's gonna be pretty straightforward. We just need to read the whole file into memory, split it by lines, and essentially just translate each individual line into the corresponding instruction and put it into the program, and then just dump that program into the file, and then we can read it and execute it. Something like that. Makes sense? Makes sense, hopefully. All right. Yeah. So don't go anywhere. I'm gonna just quickly turn on the kettle, and I'm gonna go back. I'm from Bulgaria, and I can say your city name. Oh, Bulgarian language is pretty much Russian. Yeah. Я могу говорить по-русски, и ты меня понимаешь, без всякого перевода. So, right. So I'm pretty sure, like, I don't even need to learn Bulgarian to live in Bulgaria. I can just speak Russian. Well, I mean, it will sound strange, I'm pretty sure. But Yeah, anyway. What's up? What's up, epic gamers? How's it going? Russian sounds similar to Wolfgang's Russian. Who's Wolfgang's? I don't know who that is, I'm sorry. I don't speak Russian. Okay, so what do we have? Let's try to parse the assembly. We can try to parse the assembly first from a string. How about that? I think that's a good idea. So we're gonna have a string. So this is gonna be like a source code. Source code. Excuse me? Fuck. Fuck you said to me, you. Okay. It's been clear whether he has American accent when speaking Russian. Did I have American accent? It's okay. It's kind of difficult to switch between the languages, right? So I wouldn't be surprised if I really had some accent when speaking Russian. Okay. You've had weird accent. Fuck. God damn it. Did I forget how to speak Russian? I wouldn't be surprised if I forgot how to speak Russian. That's actually fake Russian, yes. Okay. Alright. So I need to put some new lines here. So this is how we're gonna do all of that. So because I will need to split that by lines anyway. So here's the source code. So we need a function bm translate asm to, let's call it translate asm, right? It's going to be translate asm. So and we're going to have a source code. So we accept the source code and program and program size. What do you mean by VM for my Lisp in C? What I meant is that I'm making virtual machine for my Lisp in C. Sorry. Fuck. Of course, he tells us that Russian is his native language, but we know that he will not read this message without... God damn it, debated. Alright, program size. Fucking got me. I mean, I couldn't tell whether it's Russian or Bulgarian. I mean, I don't speak Bulgarian. Or maybe it was Bulgarian. Who knows? Okay, so what I want to do here, I want to try parsing the instructions and shit, right? So what we're gonna do here is a bm translate. Translate. To be fair, I think we have to put a capacity here. Right, we're going to put a capacity here, and here we're going to return this size that we managed to parse. It's quite important, I think. Alright, so it's going to be bm translate asm, source code, and then bm program. So here's the program, it's going to be pointer. And bm program capacity. So this is how it's going to go. And then we'll be able to do bm program size. You see? You see? Isn't that cool? Isn't that cool? So this is how we're gonna actually translate our assembly. So your VM is a fourth line. Have you ever implemented VMs? I mean, okay, we need to split things by lines, right? We need to split things by lines, and I heard there's something like strchr, right, to find a particular character. So this function is super sus For some fucking reason, it accepts a constant char and returns a non-constant one. Can anybody tell me why the fuck it is like that? Returns a pointer to the matched character or null. Terminated null byte is considered so. Okay, why is it designed so weirdly? Like, why? Breaking memory safety. Aren't const ignored on return? Maybe. What the fuck is this shit? Mr. Decoding. Did it say Mr. Decoding? I didn't see that. That's kind of dumb, yeah. I'm not gonna lie. Mr. Decoding. The coding. The one and only. Alright, I've got the tea. Everyone calm down. Everything's okay. Okay, so let's actually try to find this shite. So, maybe while this thing not equal to null, we're gonna do this source code. Please find the new line. So we're gonna take the end, right? So this is the end essentially, right? This is the end. And I suppose the size is end minus source code. End minus source code, and we can try to print that. We can do f right. Let's do printf, I think. So it's gonna be something like this. Can you use the variant of str that limits the search? Which one? Let's see. str. It's the second one. Returns a null pointer. Then it returns a pointer to the null byte at the end of rather than null. I see. Wait a second. str doesn't handle null pointer? Is that what you mean? Old newbie, thank you so much for Twitch Prime subscription. What happened to his hair? Well, it is what it is. And it isn't what it isn't. Okay. Let's continue. So returns a pointer, returns a null pointed matched. The terminated null byte is considered part of the string, so that the function returns a pointer to the terminator. Is a pointer to the matched character or a pointer to the null byte at the end of it. I think yeah, this one should be better. Thank you. str null. That's like this. Cool. Alright, we also have an end, and essentially what I want to do, I'm also going bold. Sure. Cosplaying your favorite closures. Yeah. Alright, so this is what we're gonna do here. I think it's something like this, right? And it's gonna be n. Well, it has to be integer, I think, to work properly, but not necessarily. And the source code. And after that, the source code, mem shr. Chr. Well, the thing is, we don't know the size of the source code, right? So we don't know the size of the source code, but we know that it's null terminated, right? So I know that they do not save, but well, it is what it is. And we're not like concerned about safety right now, so we're gonna be concerned about it a little bit later. But we don't know the size of the receiving buffer. Okay. You won. Sure. All right. So this is gonna be source, and let's actually be a little bit more safe. Okay. Source size. Yeah. So okay. So we can do something like this, and well, for this specific one, we can use strlen then. Okay, so next one. memchr. So what does it return? It also returns a void. Okay. So this is going to be source. We're looking for new line, and we're doing source size. Right, we're doing source size. Does it return? Accept that. Okay. What does it return? Returns pointer to the or null if the character doesn't occur. So you also have to check for null as well. So that's quite important. Right. In case of and not equal null. Right. In case of and not equal null, this is what you do. Right. This is essentially what you do. Otherwise, well, that one is very interesting. Oh yeah, source code becomes end, and memchr. Yeah, this one becomes end, and source size. So this is a source size. Query replace source code. This is going to be source. There we go. And this is a source size, and we have to subtract, I think, n, but also plus 1, right? Because it probably doesn't. Well, yeah, it has to be something like this. Cool. So if it is null, right? If it is null, it's actually kind of a different situation. That means you have something like this, where you have a source size and just source, and you can just do it like that. And yet you can also orient yourself around something like this. Right, memchr. Source and source. To be fair, we can abstract all of that away, of course, but this one will become 0 in any way. I think we managed to split all of that by lines, hopefully. So that's my goal, at least, anyway, and it doesn't even compile. So maybe that's what you want. Oh yeah, because it expects int, so we'll have to do something like int. Right, and then we're also gonna do something like this. Does it compile? Program, yeah, this thing is unused, this thing is unused. How about this one? Yeah, so this is a source code. And then we have to do strlen. We know that the source code is not terminated, so here it is totally okay to do something like that. So program size. Oh yeah, it doesn't have to be like this. Yeah, because it's just that. It's just that. And okay. I wonder what happened. Is that because of this? Oh yeah, it was because of this. So we managed to separate everything by lines. Look at that. We managed to separate everything by lines. Isn't that amazing? Isn't that amazing? I think it's quite cool. So, yep. Do we have any hackers in the chat? Is that a safe code? Is that a safe code? Is it safe enough? Assuming that we don't have any vulnerabilities in Lisp. Right. It's not Rust, therefore no. Okay, very well then. I'm okay with that though. Imagine any safe code. Yeah, I see. Finally, I have a hot tea. Static Stack Overflow. Yeah. How long have you been using Emacs? For 3 hours, 18 minutes. That's for how long I've been using it. I think I can simplify some of the shit here, I think. For example, I can do something like size tn, and if and is not equal null, I can just do and minus source. Otherwise, it's gonna be 0. Yeah. Okay. Oh, that by the way, and in that case, it has to be just source size, right? It has to be equal to source size, right? So, which means this is pretty much the same, right? So you don't need n, and you can just use it like that, right? Thanks for true test. Make the from a final. For a true test, take n from the final. Okay, I'm gonna do that after I squash this code a little bit. I want to first squash it. Alright, so so this is a +1, but at the same time, if it's null, yeah. Here's an interesting thing. Yeah, I still need to distinguish. Get line, where's the get line? But we don't have stream. What are you talking about? Where I don't have a file. I'm parsing the strings. So, is this code on your GitHub? I didn't put it on GitHub yet. I'm gonna put it soon. I wanna first clean it up. But after, like at the end of the stream, I'm gonna actually definitely put it on the GitHub. All right. So let's go. I'm just thinking how I can simplify the code. I like to have a simple code for these kind of things, because the simpler it is, the easier it is to analyze, right? The easier it is to analyze and find any bugs, if you know what I mean. If you know what I mean, then, so if we printed that, we can make the source equal to end, and then source size subtract n, right? So basically we moved further. And if source not equal null, right? If source not equal null, we can try to increment it even further, right? Because that means if it's not equal null, that means we found this character right there. We found this character right there, and it makes sense to do something like source +1, source size -1, even if you know what I mean, right? If you know what I mean. So if I try to run that, it does run, but we have some problems here. So end. Apparent changes size from long to size t. So this is a size t, so it has to be size t in this particular case, right? That's what you mean. Unused parameter, unused parameter, unused parameter. This one, we're not going to use that anyway, right? And there we go. So true test, right? People wanted a true test. Let's take a look at the true test, and it worked. Is that a good test? Is that a good test? So looks good to me. So I think it's a little bit simpler now. I think it's a little bit simpler. It like has less branching, right? I mean, it has pretty much the same amount of branch, if not even more, but if you know what I mean. It's pretty cool. It's pretty cool. So yeah. Now, I think we need a way to parse an instruction, right? We need a way to parse an instruction. So I think I'm gonna call it translate source, right? We're gonna accept the source. This is a single source. So I'm gonna separate all of that. Inst bm translate line. Right, and here we're gonna have the following thing. We're gonna have a line, t line size, and that will return us this particular thing. All right, so I also want to be able to trim this entire stuff, but the question is, how can I easily trim it? So for now, oh, I just realized that we don't have nope. So I cannot even do something like make instruction nope. So I think we should be able to do something like that. And I think nope instruction has to be the zeroth one. Yeah, definitely. Now you're wishing you had AIDS, right? Yeah, I kind of wish I had AIDS. I mean, by AIDS, I mean my replacement for std. It's a standard library that I'm developing for C++. But I'm already doing all of that in C, so it's okay. Okay, so here is the nope, and it has to be 0, by the way. It has to be 0. So this is that. Inst nope, and let's do return inst nope. There we go, and let's recompile that. So what else do we have here? So we also need to interpret nope. It's going to be inst nope, and it's going to be break. And what we're going to do here, we're going to literally just increment this. We're going to just go to the next instruction. We have anything else? Make inst nope. Sure. Why does nope have to be 0? Because if you have 0 initialized region of memory, it's a valid array of instructions, and all of the instructions are nopes. Do you see why it makes sense? You see why it makes sense? So you have an array, well, you have a region of memory, it's completely 0 initialized. You cast that to an array of instructions, and it's a valid array of instructions, and all of the instructions do nothing. And it makes so much sense. Yeah, hopefully it does make sense to you as well. 0 is add ALA in x86. Yeah, nice one, x86. Okay. Oh, what's funny is that, like, in our case, an instruction always has one operand. Because if an instruction has several operands, you can always get them from the stack. You can always get them from the stack. Okay, so let's do that. Define, and this one is essentially, and you know what? This is another reason why it's 0. Seriously, I'm not even fucking joking. Nope. This is another reason. How about that? Oh, I think it's not gonna work that easily. I think it has to be like this, yeah. In C at least. Well, I mean, it also has to be casted to an instruction, yeah. Okay, whatever. So, how can I trim everything now? So I also want to be able to trim, but I'm pretty sure C doesn't have a trim instruction or anything, so you have to actually kind of suffer, right? Alright. Ltrim, okay, let me see. Ltrim, I don't see it. Ltrim CL trim. Why don't I have a, like, where is it? Are you sure it does exist? Okay, well, CPP reference. I feel really debated. I don't like to feel debated. Is that a thing? It's not a thing. Cool. We're gonna use memchr then. I guess I got debated. Alright. Alright, so we provide the line. We're looking. Oh, god damn it. Alright. So let's actually implement the trim then. So we're gonna do trim, I guess, begin, right? And it will probably return us. Yeah, it should return us the position at where it starts, and we're gonna accept a string and also a string size, right? Str size. So we're gonna trim the spaces, right? We can also call it ltrim, since we got debated. At least we got. Well, I don't like this C naming, to be fair. I'm gonna call it trim left then. All right. For size, 0 less than str size, and stri is space. To be fair, we can do that slightly differently. So if not a space, we instantly return str plus I. Otherwise, we return null, right? So we have to be super careful. Okay, good. To be fair, I don't like the idea of memchr returning null and shit. So maybe we're gonna return actually str plus str size, because in that case the result of trim left subtracted at the beginning will be actually 0, I think. Yeah, it will be equal to str size, and then this is how we can know that it's actually empty, right? If you know what I mean. We'll see how it goes. So trim left. So it's going to be end. So str line size. Right, and I want to put it like this essentially. Line size minus. End minus line, like this, right, and then line equal to end. So this is how we can trim all of that, right? So we have end and we have that, and this is where we can do the following thing. If line size is equal to 0, yeah, it's actually equal to 0. This is a straight up thing. Like an error, std error, could not translate empty line to an instruction, right? So this is going to be an error, and it's going to be a punishable error, meaning that we're going to exit on that. Okay, cool. So the next thing we need to do, is find a space. All right, we need to find a space or something else. So it's going to be char, and I really dislike memchr returning null at the end. Okay, I really dislike memchr returning null when we cannot find it. So is there a version of memchr that doesn't do that? is like except that it searches backwards. Okay, it's similar to it assumes. It's really inconvenient. I think it's super inconvenient in my opinion. It's just like it makes you do extra work. Just return me the memory plus the size so I can just do this kind of shit. I don't know, it's kind of a bad design in my opinion. It's kind of a bad design. Why do we need custom wrappers if we can implement our own things? If we can implement our own things. Maybe I'm gonna implement my own string view. So that sounds like a cool idea. So the frame rate with the camera is actually kind of fucked up for some reason. Yeah, looks like the time has come to implement our string view, chat. I think the time has come because I don't want to deal with this shit. So let's implement string view. All right. So then we can actually split everything by lines and shit like that. 8 for C. Well, yeah, it's gonna be like 8 for C. String view. Okay, so it has to be actually like this, right? So string view, and so it's gonna have like a count, right? So this is the count, and this is gonna be data. So, and we can do something like this: sister as string view. So we'll definitely need this thing here. We're gonna accept this sister. I'm gonna accept the sister. And this one is actually pretty straightforward. It's gonna be string view, right? And count is gonna be strlen sister. I'm not sure if it's gonna compile because maybe it will have to accept the other stuff. It has to be constant, I mean, that's what I wanted to say, and this thing is that. Alright, so another things, we need, so let's actually call it as SV, because I don't really like to type string view as often. So SV trim left, right, so we're gonna accept string view, and it accepts SV, and we're gonna return another SV that is already trimmed for you automatically, right? So something like this, we'll need to implement that. SV string left, not implemented. What is another one? What is another thing that we'll need? So this one has to be a string view. That's right. String view. Chop by delimiter. This is another one. It's a very important one. It's actually super useful function. You won't believe how useful it is. It's insanely fucking useful. Chop by delimiter. So the design of strings, the design of string functions in C is kind of meh, so that's why I like to implement this thing myself. So we need only chop by delimiter, and that should be it. That should be essentially it. So I don't need this thing anymore. And by the way, here I can essentially accept string view line. Right, so we don't need that thing. Right, and in here we can accept source. We can accept source also as a string view. So this is going to be a source. Right, and while source count is greater than 0, we're going to do string view line SV chop by delimiter. Well, was it chop by delimiter? It's SV. There has to be SV chop by delimiter. We provide a pointer to the source, right? And that is it. You don't need literally anything else here. That's how beautiful it is. It's line count, line data, and you don't need that shit. You don't need that shit. You don't need any of this shit. That's how beautiful that interface is. You only need to implement these things. So look how simplified all of that becomes. Holy fuck. Okay, so then you can do line equal SV trim left, you just trim this line. And then you can take the instruction, right, well, has to be string view inst name. You need to get the name, but the way you're gonna get it is sv chop by delimiter, where the delimiter is a space, right? You use this space as the delimiter. Well, yeah, you have to first take the line, the pointer to the line, and here's the source. This is a new line. Like, look how simple it is. You just need to have like a small set of very simple operations, and if they're designed well, your code is so concise. Holy fuck. Yeah, it's just like some parts of C library are not really designed well. They're not designed well. And also, I think the main mistake of C library is like reliance on null-terminated strings. They're not really that great. Well, maybe they were useful back in the days when computers didn't have that much memory to store the size of the string, but yeah. Anyways, so here it is. I chop a delimiter, here's the name, and I need to do something like sv equal, like if sv equal, I provide inst name sister as sv, and what I'm comparing this entire thing with, I compare it with push, and then I can do something else here. So here is another instruction that I need to get right. So so this is going to be int sv equal string view a string view b, and there we go. This is the third operation that we need. We only need 3 operations to parse all of that, nor more nor less. Okay, okay, cool. Let's go ahead and implement them. Maybe not. Maybe a little bit later. Okay. So, and then can you remove cast line count to printf? And no, I cannot remove that because it accepts integer, not size t, and this is size t. But we can make this thing integer. But what having a negative count means then? I don't think it makes sense. All right, so in this case it's just that, and then we need to trim one more time. We need to trim one more time, and so if it's a push, what we have to do? So we have a to I. We have a to I. Unfortunately, a to I accepts a null-terminated string, so we need to have something like sv to integer, right? So so we're gonna do line. So we can also, it depends. We also need to properly trim it or something. Sv chop integer. I'm gonna do it like this. So this is gonna be an operand. There we go. Operand. And we need to return what? We need to return make. Maybe I can do it like that. It's gonna be type equal instruction push, and operand is going to be equal to operand. So this is what we have to return here. A to y, s to y. Do you guys even listen to what I said? Holy fuck. Okay. So fprintf std error. S is not a number. It's like, yeah, people just don't listen to what I say. They just want to have an opportunity to say something in the chat. It's almost like I explained why I don't want to use A to I, and no, use A to I. Like, I just explained why I don't want to use that. Like, where have you been? Excuse me. It's really strange sometimes, like, it's people just don't want to listen to you. Okay, it's not a number. Okay. And what we need to do here is essentially, yeah, instruction name. Here's the instruction name, and it's going to be count. Instruction name, data. There we go. And then we can exit one. So it's basically assertion that we don't know what the fuck it is, and then we can return all of that. So the only thing I want to check is that this entire stuff compiles. Does it compile? It doesn't compile, of course. Const qualifier for pointer target, blah blah blah. Okay, so we can say that this thing is const. I don't mind this thing to be const. Unused variable SV, that's okay. That's okay. Also trim, no, trim doesn't have to be like that. So unused variables, that's totally fine. What about this one? Too many arguments for delimiter. Okay, that's very strange because we need to have the delimiter here. Here's the delimiter. Okay, here's the delimiter. Okay, there's another one. So yeah, and this is why we have to cast it to integer, right? Because it's really unsafe to do it like that. Unused variable, unused wait. So yeah, so source code, sister as SV. So we don't have to do that anymore. So all of that is unused. Implicit declaration, chop integer. Okay. So this is another one. So we need to implement 4 operations here. So this is going to be an integer, string, view. It's a pointer SV, assert. Okay. Unused. Okay, so it does compile. Cool. So everything compiles here. And now we just need to implement these things. You know what I mean? Let's go. To be fair, I don't want to do chop integer. I think it has to be an integer, which actually means that I have to implement trim right, which is going to do a similar thing as trim left, but is going to do that to the right, if you know what I mean. Okay, so undefined chop int, sv chop int. So this one has to be something like this. There we go. But sv trim right. Yeah, there we go. Okay. Sv. Was it 2 int? It has to be 2 int. Okay. Cool. So there we go. We have to implement 5 operations here. So left. So we're gonna start by, I guess, doing something like this. I want to also have like smaller operations, something like chop left. You're gonna accept this thing here, SV, and amount of characters you want to chop from the left. I think this one is going to be actually very convenient. In the long term, of course, in the long term. So what it essentially, it may actually return you the thing you want to chop eventually. But maybe not. I think it's too much to implement. So maybe later, So trim left. We start with I, right? We start with I, and while I is less than sv count and sv data, actually something like this, is space I plus 1. There we go. So, and after that, what we need to do, we need to construct a new string view. We need to construct a new string view where the count is essentially sv count but minus I, right? But minus I, and the data is sv data plus I. You see what I mean? You see what I mean here? You see what I mean? So this is a trim left. Does it make sense? Does it make sense? Hopefully that makes sense. Trim right. It's kind of a similar situation, I suppose, but in the opposite direction. So size t, while I is less than SV count. We need to do SV data, SV count minus 1 minus I. So we're just doing that from the opposite direction, and while it is a space, right, while it is a space, we keep increasing this thing. So we're looking at that from the different angle. Right. And then what we need to return is string view. Count is also going to be decreased by I. Right, count is going to be decreased by I, but what's funny is the data is going to stay the same. You see? This is trim right. This is trim right. So essentially we're iterating from the opposite order, opposite side, and in that case we don't even need to modify data. Right, we only need to modify the count, and it automatically just trims from the right. And you can also quite easily implement SV trim, string view SV, and because it is essentially SV trim left, SV trim right, and that's it. So for people who wanted both of the sides, there we go. So here it is, you just combine them. What's great here is every new string is created as a relative difference of another. Yeah, that's why I like string views. They're extremely useful. So chop by delimiter. Chop by delimiter is actually kind of stream center. Yes, is actually quite difficult, but I think we will be able to do that. So here's that. So while I is less than the SV count and SV data is not equal to delimiter, right? Is not equal to delimiter. We do I plus 1. Okay, so and here you have two situations. Is A less than SV count? If it is, that means SV data is equal to the delimiter. So that means we have to do the following thing, where we're gonna have a result. We're gonna have a result, right? We're gonna put it like that. Result equal to count is I, right? And the data is the SV data, right? It's gonna be SV data. But on top of that, we need to update the SV itself. So the count is going to be actually decreased by I plus 1 because you also include the delimiter. And SV data is going to be increased by I plus 1 because it includes the delimiter. So otherwise, I is equal to count, so that means that condition was like never happened. It never happened, and we have to repeat this entire thing, but without including the delimiter, because this time there was no delimiter. And we are repeating a part of the code in both of the branches, so we can actually move this thing here, remove that, and there we go. You have a chop by delimiter that actually excludes the delimiter as well, and also takes into account the end of the string as well. All right, so here is another thing. So if A count not equal B count, instantly false. Otherwise, I think we need to try to do something like memcp CMP. Memcmp. So in that case, it's going to be A data, A B data, A count. I bet somebody in the chat will just tell me, but CMP is unsafe, without even trying to understand the code. Because every time I implement this function, somebody in the chat starts reading that memcmp is very unsafe, and they don't even understand like this part. Like, it happens every fucking time. It's so fucking funny. Please tell me that memcmp is unsafe and I shouldn't use it. Please tell me. All right. So oh, not equal. Yeah. Thank you so much. All right. Wait a second. Jiang, what the fuck? I didn't expect that from you. I can't believe you've done this. I can't believe you've done this. Alright, so we're gonna have a result, and here is the thing. Brain force, okay, don't worry about it. Alright, while I is less than SV count and SV data is digit. What we're doing here is result multiplied by 10 plus SV data minus 0. Alright, so then, since we're... Yeah. That's very interesting, actually. Yeah, it should be. We can do something like this, I suppose. Yeah, then we can just return the result, I think. So we don't really need that shit this much. Okay, so this is gonna do that. So, yep. Is it gonna work now? Is it gonna work now? Yo. Okay. So we need C types. C type. Is it C types? It's C type. Thank you, MK and thank you for the kind words. I really appreciate them. I really like your nickname as well. I think it's super cool. Unused variable result. Nice. So after that, we should not forget to return the result. Cool. And there we go. Cool. So now, once you have a line, right? Once you have a line, essentially what you have to do, you have to do program. So we're gonna have a program size. Program size initially 0. Program size is gonna be plus bm equal bm translate line line. There we go. And then we're gonna return program size. Yeah. Unused parameter program capacity. It is in fact true, and we're gonna assert that program size is less than program capacity. There we go. And all of that compiles without any mother flipping warnings. How about that? How about that? Okay, so if I try to run this shit, right, it is error. This shit is not a number because I did a fucky wacky yet again. Yeah. Push. Okay, so it didn't manage to separate it into the lines properly. I see. It didn't really chop by a delimiter as well. That's very interesting. Okay, if I try to print f, so now we're doing like a troubleshooting time. So it's gonna be this, and let me see what is going on here. It's gonna be line count integer, quite important, otherwise it doesn't count. So can we separate all of that by lines? We cannot separate anything by lines because we fucked up implementation of chop by delimiters. Okay. So we're iterating through all of that while it's not equal to the delimiter. Once it is equal to the delimiter, I see what's going on. It has to be I. So let me double check everything else. So I think I'm an idiot. Yeah, I don't know why I decided to do it like that. Everything's okay. There we go. So we managed to actually split everything by lines properly. And now, RT, lit. Thank you. Thank you so much for 9 months of... 9 months of Twitch Prime subscription. Thank you, thank you, thank you. And welcome to our epic virtual machine club. We're actually implementing assembly for this bad boy. And we are about to... dupe is not a number. Yes, that's exactly what I'm talking about. That's... okay. I have to actually do something like this. Error, unknown instruction. That's what it has to be. Dupe. Unknown instruction dupe. There we go. So we have everything. Look at that. We just implemented some basic operations and look how easy it is now to parse all of this shit. Holy fuck. So you don't really need a special like capabilities for the language to be able to parse things. You just need a proper functions. Like holy fuck. You don't need much. Just a little bit. Just sprinkle a little bit, and it's so convenient and it's so easy. Absolutely beautiful. Absolutely beautiful. So let's continue, chat. Let's continue. So next one. Else if sv equal instruction name and inst name sister as sv, and let's implement dupe, right? So in case of a dupe, I think dupe accepts an operand, right? Yeah, it accepts an address as well. So let's quickly do that. So we have to trim this entire thing. It's going to be trim left, right? It's going to be line, and operand is pretty much the same. Is that the difference is going to be it's going to have like a different type of the instruction. Okay, inst name, that's what it is. Unknown instruction plus, cool. So in case of plus, we don't even need an operand. It's operandless instruction. So a boom plus. So in here we just have to return that. And just plus. Unknown instruction jump. I think jump is does have an operand. It does in fact have an operand. So let's actually do jump, and it's gonna be jump. Now we're there we go. We managed to translate everything. How about that? We managed to translate everything. So we might as well try to ignore empty lines. So we're gonna do trim on all of the lines here, and if line is equal greater than 0, only then we're gonna put it into the program. Right, only then we're gonna put it into the program, so we can have like these kind of lines. Cool. Look at that. Isn't that amazing? I think it's goddamn fucking amazing, mate. So, translate source. But we only can translate source. So now we need to be able to slurp the file. Right. So let's implement the following thing. It's going to be something like char slurp file, right? So it accepts that as a file. Actually, it should accept const char file path. Let's quickly implement that. We'll have to do like a malloc at this point. Slurp, yeah, basically like read the whole file into memory. This is usual like a terminology of this stuff. So here's the file. We're gonna open it. File path for reading, right? Close file. So exit 1. Let me find the could not read file. So this is basically what we can use here. So if file equal null, okay, it's the same ftl shit actually. So we'll have to fseek ftl fseek back. I'm gonna just steal this code from here. excuse me, and we're gonna fseek, ftell, fseek back. Okay, so then we need to allocate the buffer. Yeah, let's call the buffer. We will have to malloc buffer equal null, and it's gonna be could not allocate memory for file, and we can just do something like this. So now we have a buffer, and then we have to just read this entire stuff. So it's going to be man fread, fread. So let's just read all of this. So, and now we also know the size. Oh, I have an idea. String view. We're gonna actually straight up slurp the file into the string view. So the size is gonna be that. So the buffer is gonna be that. So size is 1. Amount of this thing is gonna be m. We're reading it from f. And if f error, yeah, if f error for the file, we couldn't read the file. So we couldn't read the file, right? And afterwards, we can just return this entire thing like so. It's going to be string view. So the count is going to be the n, and the data is going to be the buffer. And there we go. And will that compile? It does compile first try. Okay. Now look. So what should we be able to do? I want to accept this entire stuff. So I'm going to remove BM. Okay. So I only have ebusm. So this is the only thing I have. I only have this file. Now I'm going to accept command line arguments. It's going to be end rgc char rgv. Right. And yeah, if rgc is less than 3, we're gonna print error, std error, expected input and output. So we're also gonna print the usage. I think the usage is gonna be somewhere here. It's gonna be usage, bm, input, ebusm, output, bm, and then we're gonna exit with 1. So, and then we're gonna have const char input file path rgv1 output 2. There we go. So we're gonna have a source slurp file from input file path program size. Okay, so we can actually do that separately in my opinion. So size, program size, and we want to translate that to a program. So let's actually create some sort of like a program here. Inst program. To be fair, whatever. Let's actually do that with BM. All right. So, and then BM save program to file. How do you use this function? I'm going to put it like that. Yeah. So save program to file. You provide the program from BM program and BM program size. And we use a file output file path. Cool. There we go. So now we have an actual assembly for our virtual machine. So now, look at that. I can compile that. Source is not used because I'm bebega. So let me remove that source code. So we're about to actually translate our first ever assembly program. Okay, so as you can see, it tried to run it and it couldn't because it doesn't accept anything, right? Cool. So you see, it accepts input and then output. All right, cool. So you see, we have only ebusm, right? We only have only ebusm, which is like the asm thingy here. And then if I try to run bm fib ebusm, and I forgot to provide the output, it's going to be fib bm, and it generated a bm file. So it took the assembly and translated it into the code. So I think we should have like a separate executable for interpreting this entire stuff. So I think yeah, I think there should be like completely different executables. So I'm thinking how we're gonna organize all of that. So it's gonna be bm.h. So I'm thinking, let's actually do bmc. Bmc, right. And we're gonna move everything related to BM there, like literally everything. Like all of this stuff, because it's gonna be shared between both of the executables. So this is our small virtual machine. That's a lot of shit actually. Holy fuck. Oh, okay, so we're starting to, well, no. So all of that is still, okay, there we go. I'm gonna put it here. So that's like 500 lines of code. Holy shit, okay. Now, we definitely need this stuff, so I'm gonna also put it to the BM. And we're gonna have separate executables. So the first one is gonna be ibasm.c, which is like just literally assembly. And the only thing it does, it includes bm.c, right? And we're gonna just put this thing here. So, yep, look at that. And we need to update how we do all of this. So it's going to be ibasm.c, bm.c, right? And here it will create you ibasm executable. Ibasm, and it also includes bm.c, so we don't have to worry about that. All right. So, and another one, I suppose, is going to be literally bm. Well, I mean, it's already bm. How are we gonna call the executable that is actually interpreted? I really need to be able to... Well, you may go. You may go. Don't worry about it. So I need to come up with the name for the interpreter. BM to ibasm. BMI? Why BMI? Interpreter? Okay, let's call it BMI. BMI. Yeah. So this is gonna be. BMI. Alright, so this is gonna be just that. And the let's see. Body mass index, yes, very funny. BMC, and we have to actually load that stuff from arguments. If RGC is less than 2, ibasm. So this, by the way, this thing is ibasm BMI. Input. Expected input. RGB1 make file. Boom. All right, look at that shit. We have only fib ibasm. Only fib ibasm. What do we do? We are calling ibasm on fib ibasm and translating it to fibbm. That happened successfully. So here we go. Here we have this thing. Now I do BMI and I give it fibbm. So we have our own assembler and we have our own interpreter. Pretty cool, not gonna lie. So we can try different programs. So something like 1, 2, 3, ibasm, right? So you can literally just do something like push 1, 2, 3. So we have just 2 pushes, right? And maybe you can do plus and just 2 pluses, right? Just to see if it actually produces a different thing. So we're gonna do ibasm 1, 2, 3, 1, 2, 3 bm, all right? And it translated it to this. So it gives us this kind of instructions, and if we try to execute this file, BMI. Yeah, there we go. So first it pushed 1, then 2, then 3, then it summed up these 2 things, and then it summed up these 2 things, and end result was actually 6. So you see, we can quite easily write in our own assembly, then turn it into the binary code, and then execute it at our will. So yeah, that's basically what it is. Isn't that amazing? Isn't that amazing? I think it's quite cool. Ibasm mod when? We'll probably have to implement it at some point, that's for sure. So let me actually create examples folder where we're gonna keep something like this. So I'm just thinking how we're gonna do all of this. So we're gonna put that one and that one there, right? So these are gonna be the examples. Then I'm gonna git ignore all of the BM files, and also we need to ignore BMI and ibasm. Yeah. So we need to also build all of this stuff. So we're gonna have like all, by the way, is a phony target. So this is a phony target. A phony target is assembly. Well, we can implement it as well at some point, but I mean, I will already stream it for 4 hours. So this is gonna be a phony, and it's gonna be example. So and to build examples, we want to have what? It's gonna be examples. Examples ibasm fib bm, right? It's going to be fib bm, and another one 1 to 3. So the way we're gonna do all of that, anything starting with bm except expect a corresponding ibasm thing, and also it depends on ibasm itself. So the way we do that, we do ibasm. So here is the, oh, you're gonna do that, unfortunately, but we can try to do something like this. All right. God damn it. Okay, so it has to be examples fib, and the input has to be this. The output has to be this, and then we can just copy paste this entire stuff, and this is going to be fib 1 to 3. So if I try to do make examples, it actually makes them, and here they are. Okay, cool. Yeah, that's pretty cool. So we can just do that. All right, so let's actually write a readme. BM quick start console. We can try to do something like make examples. Ising Grims, thank you for tier 1 subscription. Thank you, and welcome to Epic Virtual Machine Club. And it's gonna be something like BMI examples fibs BM. There we go. And the license is gonna be MIT license. Come on. Come on. Come on. There we go. So year is gonna be 2020. Alexei Kutepov, gmail.com. All right. Come on. Oh, I don't have a git repo here, so let's do git init. Let's do git init. So we have that, and that. Cool. So let's do ready, set, go. So we committed everything, and I want to do git clean fdx. So we removed all of this bullshit. So everything looks okay. We might as well actually create src folder and keep everything there. You know what I mean? Like this, and just like move everything there. And in the make file, when we refer to C, refer to C files, we'll have to actually refer to them through src, right? And let's just do that. There we go. So that's a little bit better. And I can also build examples. There we go. That's actually epic. Then git clean. Well, I mean, first I need to introduce src folder. There we go. And then I can do git clean fdx. And yeah, there we go. All right, you guys are ready? I'm gonna create a repo. BM. JustPen1 subscribed with Twitch Prime. Thank you so much, and welcome to our epic virtual machine. Virtual machine for Lisp. There we go. So it's gonna be public, of course, and let's just create a repo. It's a virtual machine. Okay, so let's copy that. And it's gonna be add origin to that. Okay, and let's push that right into the repo. Are you guys ready? Are you guys ready? Are you ready for the pushage? Pushage. And wait, is it pushing? It is pushing. It's just actually takes too much time to push it. There we go. Would you look at that? We did it. So all of the source code is available here. You can play with it. Yeah. So I'm open for suggestions. So feel free to submit issues, pull requests, and stuff like that. We can discuss all of that. So I implemented all of that in 4 hours, 20 minutes. Nice. Isn't that epic? Isn't that epic? I think it's pretty epic. That's a sign of a god coder. How about that? The weeb number. Yes, it is the weeb number. Right. So I also want to actually add this description to the README. The virtual machine for a Lisp, and we also can give a link to git https github.com sodding ebisp. Add description to readme. I'm gonna push that right into the repo. Look at that. This is my first virtual machine, by the way. I never implemented virtual machines before, and I actually kind of enjoy it. I have a lot of ideas. Git push, yeah. So let's actually follow these instructions to make sure that they do work. So the first instruction, make examples, right? So, and, okay. So they do not work. Nice. All right, let's fix them. All right. I see. Come on. Okay, so essentially you have to build a boson first. Okay, and then you can do a boson fib examples fibs bm. It's actually BMI. So in instruction we have BMI. Yeah. So in instruction we have BMI. I see. Okay, so let's actually add another step to the instructions. Make. Okay, cool. So we have to make everything first, then make examples, right? and then you should be able to do BMI. Okay, that's cool. Fix quick start instructions. There we go. Let's dive right into the Reaper chat. Now, the quick start instructions do work. They do, in fact, work. How about that? How about that? It was actually super fucking fun. Holy fuck. I really enjoyed what I was doing. So, yeah. 500 lines of virtual machine. It's actually, like, it's really unfinished. Like, it lacks a lot of shit. But yeah, it fucking works. It fucking works. You know what? I think I'm gonna stream this virtual machine tomorrow as well. I'm really sorry if you wanted to see Rust tomorrow, but I want to kind of continue doing that tomorrow. Because I kind of want to finish it because it's going somewhere. It's actually super cool. So I guess I'm gonna, yeah, I'm gonna like make a off schedule another stream of this virtual machine. Yeah, it's super fun, and I have so many ideas and so many places we can take this virtual machine to. It could be like an abstract virtual machine. So yeah, you can find the source code here, by the way, so it's available here. All right, so I'm gonna update the schedule a little bit later after the stream. But unfortunately, boys and girls, it is time for me to go. Thanks everyone who's watching right now. Thank you so much for all of the subscriptions, all of the bits, all of the donations. Holy fuck, you blew me away. I didn't expect to earn this much this month. Thank you so much. Check out our so I see you all, by the way. I see you all tomorrow. Tomorrow, according to the schedule, we need to do like a TUI development, but who the fuck cares about that? Let's continue doing this virtual machine. How about that? Let's continue doing this virtual machine. Virtual machine is fun. I love virtual machines. And also, this is my first virtual machine. I never implemented them before, and I finally have an opportunity to learn something new. All right, check out the schedule for more projects we're working on. I'm gonna update the schedule later. Also, check out our VODs channel where we upload all of our streams. This stream is going to be there, but tomorrow we upload them on the next day. Subscribe to this channel if you don't like to watch VODs on Twitch, because you can watch them on YouTube instead. It's more convenient for majority of people. Well, at least it's more convenient for me. And check out our Discord server for offline discussion with the community. And while you're waiting for continuation of an epic virtual machine development, let's maybe rate somebody. Who should we rate today, boys and girls? Do you have any suggestions on who to rate? Togglebit, but I think we already Togglebit recently, so maybe the time has come to rate somebody else. Toggle just finished. Okay, so that means we will try to rate somebody else then. All right, let me close my music because I think it consumes a lot of CPU and stalls my machine. So Dennis, we're ready. Dennis, yep, Blender, yep, Blender, game dev and C++. Is anyone doing like virtual machines or anything? Java. Spider ID, what are they doing? What are they doing? It's more important what they're doing rather than their nickname. C++ 20, Unicode bidirectional. This sounds interesting. C++ 20. Are they praying to the C++ gods? I can respect that. You know, I also pray to C++ guys from time to time, so I think we can read them. Please, holy compiler. Praying to Strauss to itself. Yeah, exactly. All right, I do respect that. Let's read them. So they're doing C++ 20. How about that? All right, boys and girls, get ready for the raid. And I see you all tomorrow. Love you.